In 1977, a signal unlike anything else reached Earth, and some scientists believe it came from 3E Atlas. Avi Loeb suggests this interstellar visitor might have been sending a message long before we even knew to look. What was its purpose? Who or what was it trying to communicate with? And could humanity have intercepted a cosmic greeting by accident? Stay with us, because what 3I Atlas might have revealed could change how we understand intelligent life in the universe. The night the sky spoke. The date was August 15th, 1977, when an ordinary summer night in Ohio turned into one of the most extraordinary in the history of astronomy. The Big Ear Radio Telescope, a massive fixed structure designed to survey the sky, was engaged in its nightly routine of scanning background cosmic noise. No one expected anything unusual, yet, at 10:23 p.m. Eastern Time, the telescope caught something so powerful, so perfectly precise, that the astronomer reviewing the data would later be left nearly speechless. The instrument was not searching for messages from other worlds, it was designed for statistical sweeps, searching for faint whispers among static. But suddenly, the output spiked in a way it never had before. On the printed readout, one signal stood far above all the others, a narrow-band transmission at 1420 MHz, the frequency of neutral hydrogen. This was not random. Hydrogen, the most abundant element in the universe, had long been considered by visionaries like Frank Drake to be the universal meeting frequency, a natural beacon any civilization might use to call across the stars. And on that August night, someone, or something, used it. The man who noticed it, astronomer Jerry Eman, was reviewing pages of numeric codes days later. His eye froze on a string that was almost impossible to believe, 6EQUJ5. It represented a signal 30 times stronger than the background noise, lasting precisely 72 seconds. Without thinking, Eamon grabbed a red pen and scrawled one word in the margin. Wow! That spontaneous annotation would forever define the anomaly as the wow signal. Few moments in science are so raw, so pure, so perfectly human. In that word was shock, awe, and an almost subconscious recognition of significance. The strength of the signal was only the beginning. Its duration was uncanny. 72 seconds, not 69, not 84. That was exactly how long it would take for Earth's rotation to sweep a fixed point in the sky across the Big Ear's field of view. The implication was staggering. Whatever was transmitting wasn't moving relative to the stars. It was fixed at a precise celestial coordinate. Natural sources like pulsars, quasars, or magnetars behave differently, flooding wide swathes of the spectrum with chaotic output. This, in contrast, was focused, narrow, intentional. The signal's location added yet another layer of intrigue. It came from the constellation Sagittarius, a region of the sky that holds the galactic center itself. Sagittarius has been the backdrop of countless mysteries, but to astronomers in 1977, this detail meant little more than an intriguing coincidence. After all, telescopes searched all skies. The fact that it came from that part of the heavens did not yet raise alarm. Still, when astronomers rushed to aim other telescopes at the precise coordinates, they were greeted with nothing. Silence replaced brilliance. One of the most unsettling aspects was the finality of that silence. For nearly 5 decades, researchers have pointed instruments, more sensitive, more advanced, more globally coordinated, at the same patch of sky. Not once has the signal ever repeated. It was a single burst, a lone cry in the cosmic night. If it had been a technological mishap, why did it never occur again? If it had been a natural phenomenon, why was it never observed elsewhere? The silence that followed became more unnerving than the signal itself. As the years stretched into decades, theories piled up. Some suggested interstellar scintillation, a focusing effect of interstellar gases. Others proposed secret military transmissions or earthly interference that mimicked extraterrestrial communication. None fit the facts. The 1420 MHz frequency was internationally protected. It could not legally be used by transmitters on Earth. And unlike terrestrial interference, the WOW signal had the hallmark drift consistent with an extraterrestrial source locked to the stars. The further one probed, the less natural explanation seemed possible. Eamon himself grew cautious over time. He never claimed the signal was proof of alien life, but he also never dismissed the sheer improbability of what he saw. There's something that remains unexplained, he admitted, decades later, and the kind of thing that gnaws at you. Astronomers who devoted their lives to patterns and predictability now faced the one event that resisted every model. The wow signal became astronomy's ghost, a haunting reminder of something that appeared, spoke once, and then refused to appear again. The cultural impact was as strong as the scientific one. Headlines screamed of alien contact, movies, books, and speculative documentaries turned those two red-penned letters into a symbol of cosmic mystery. But beneath the sensationalism was a deeper, colder reality. What terrified scientists was not that we might have been spoken to, but that if we had been, whoever or whatever was speaking had chosen silence immediately afterward. A greeting without a follow-up, a light without a return. What makes August 15th, 1977 so unforgettable is the weight of unanswered questions. Why choose the hydrogen line? Why transmit at all? Why transmit once, never again? And why in precisely the format that theoreticians had predicted decades earlier would be the most rational way to announce oneself to the galaxy? No random star noise could hit that bullseye. If intention was behind it, then intention remains unanswered. For 48 years, the wow signal has existed in a strange limbo, too structured to be dismissed, too fleeting to be confirmed. It is neither myth nor proof, but a wound in the science's ability to categorize. Astronomers can account for solar flares, gamma-ray bursts, and the wanderings of rogue planets, but they cannot account for that night in 1977. And yet new evidence emerged decades later that breathed fresh urgency into the story. Because Avi Loeb, tracing the path of a very different mystery, discovered that on the very night of the wow signal, another object, unknown to astronomers at the time, was precisely aligned with Earth in the vast darkness of the outer solar system. That object, moving faster than most comets and unlike anything catalogued before, would one day be known as 3I Atlas. Was the wow signal not a cosmic accident at all, but a deliberate act of announcement from an interstellar traveller already within our system? Stay with us as the mystery deepens. A visitor without return. Interstellar space is a graveyard of wanderers, shards of shattered worlds, icy bodies expelled from distant suns, and fragments of planetary systems long gone. Yet among these drifters, only a handful have ever brushed against our solar system closely enough to be noticed. The second time humanity identified such a visitor, the calculations revealed something remarkable. It was not bound to our star. It had arrived from the deep beyond, would pass once, and then continue its voyage into the unknown. That traveller now bears a chilling name, 3I Atlas. Astronomers recognized early that 3I Atlas was not like ordinary comets or asteroids. Most bodies within our solar system circle the Sun in predictable ellipses, their orbits closed and repeating, sculpted by the same primordial disk of gas and dust billions of years ago. This new object's path was different. Its orbit was hyperbolic, a curve open-ended and eternal, ensuring it would never return once it escaped the Sun's pull. To encounter it was a cosmic once-in-a-lifetime alignment, an astronomical crossing of paths we could not summon again. The significance of that hyperbolic orbit cannot be overstated. It told scientists immediately that 3I Atlas originated outside the solar system, carrying with it the chemical fingerprints, structural features, and mysteries of an alien birthplace. Unlike comets we had catalogued for centuries, this one did not belong to us. It was, quite literally, an interloper from the stars, bringing into our neighbourhood a story written light years away. To watch it move across the sky was to watch the galaxy itself intrude into our realm. Mathematical reconstructions of its path revealed something stranger still. Astronomers could rewind its trajectory backward in time, tracing precisely where it had been at given moments in history. The equations were clean, the geometry exact. And when that rewind was taken all the way back to August 15th, 1977, the night of the wow signal, the results froze even hardened scientists. On that very night, 3I Atlas was positioned approximately 600 astronomical units from Earth, aligned almost directly along the coordinates of the mysterious burst. A single astronomical unit measures the distance from Earth to the Sun, about 150 million kilometers. 600 of those places the object far beyond Neptune, past Pluto, into the realm where sunlight dims into starlight. It was out there, a massive body drifting in the dark, and it happened to be aligned at the exact same time humanity picked up the loudest and most puzzling radio signal in history. The chance of such overlap, as Avi Loeb later calculated, was less than 1 in the 160. The object's sheer speed further separates it from ordinary celestial debris. As it entered the solar system, 3I Atlas was clocked at nearly 60 kilometers per second. To put this in human terms, that is about 200,000 kilometers every hour, fast enough to circle Earth multiple times before most people have finished breakfast. No cometary body in our records travelled in quite this way, at this velocity, and with this trajectory. It was not drifting lazily through space, it was cutting across the solar system with fierce momentum. Its designation as 3I marks its place in history. Before it came only 2 other confirmed interstellar objects, 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Both were puzzling in their own ways, but they were smaller, less massive, and easier to fit within the bounds of natural explanations. 3I Atlas, however, was different. It was larger, brighter, heavier, and more unusual than anything that had crossed the Sun's realm before. In terms of size, estimates placed it at several kilometers across, large enough to dwarf the earlier interstellar visitors by an order of magnitude. The discovery of this traveller set off a frenzy of observation. From observatories on Earth to the James Webb Space Telescope, every eye turned toward it. If this was only the 3rd interstellar object humanity had seen, then every detail mattered: its spectrum, its mass, its behaviour as it approached the Sun. In the scientific world, opportunities like this were as rare as lightning striking twice in the same spot. And yet this was more than a chance to study an exotic rock. It was a chance to revisit the biggest question ever asked: was the WOW signal connected? The implications of connection would be staggering. A body moving through interstellar space for millions of years had, on its way through, chosen, or incidentally aligned, to beam a narrow-band radio burst toward Earth. If deliberate, it meant intelligence. If coincidental, the coincidence was of such magnitude that it strained the boundaries of probability. For Avi Loeb, the answer was in the math, and the math screamed that the 2 events, the signal and the object, were not independent. The unsettling truth is that 3I Atlas is not here to stay. Its path will carry it through the solar system once, brushing past planets, slipping behind the Sun, and then vanishing outward forever. Like a ship glimpsed through fog, it is here and gone, leaving only the impressions of those who observed it. Scientists cannot summon it back, cannot wait for a repeat performance. If answers are to be found, they must be seized in this narrow window of months, before the object fades into the interstellar night, beyond reach forever. That reality has sparked urgency among astronomers and tension among agencies. Observatories race to gather data. Teams argue over what interpretations are credible. Some insist it is only a comet behaving oddly. Others point out that its composition, trajectory, and strange activity do not match known models. For the public, the drama remains hidden in academic papers and hushed debates. But to those paying attention, this is no ordinary cometary encounter. It is a fleeting brush with something foreign to our solar system, something that may never pass this way again. To encounter a traveller from the stars is one thing. To find that this traveller may have spoken once, long before we knew its name, is something else entirely. Why would a body arriving from the depths of interstellar space send out a signal just as it entered our neighbourhood, and then move silently ever since? Come with us to explore the hidden corners of the story. A probability that defies coincidence. In science, numbers have a way of cutting through emotion. They strip away hope, speculation and doubt, leaving only what logic allows. When Avi Loeb examined the connection between the WOW signal of 1977 and the arrival of 3A Atlas nearly half a century later, it was not a hunch that shook him, it was the numbers. The mathematics pointed to a likelihood so overwhelming that to call the 2 events unrelated required more imagination than to admit they might be linked. Consider the vastness of the sky. The celestial sphere covers 360 degrees around, stretching 180 degrees from pole to pole. Within this expanse lie millions of potential directions in which a random object might wander. If one were to throw a dart blindfolded at this cosmic map, the odds of striking near the precise location of a unique, once-in-history radio signal would be almost impossible. Yet, when Loeb traced 3I Atlas backward through time, that is exactly what happened. The object's position in August 1977 placed it only a few degrees away from the source coordinates of the WOW signal. Specifically, the separation amounted to 4 degrees in right ascension and 8 in declination. On a human map, such a gap would be like standing in New York and claiming a coincidence with something happening in Philadelphia. But on a sky-wide canvas of tens of thousands of square degrees, such a closeness is astonishing. It was not a general resemblance, it was a near bullseye. Loeb calculated the probability. If one were to select 2 random spots on the celestial sphere, the likelihood that they would land within such a margin of alignment is only about 0.6%, less than 1 in 160. That may sound like a small number, but in statistics, anything approaching 1% already indicates extraordinary correlation. Here, the odds argued against randomness with brutal clarity. What was seen that night in 1977 and what drifted through the solar system nearly 5 decades later were not strangers. Probability becomes even more compelling when layered with context. Not only did 3i Atlas occupy nearly the same patch of sky at the exact time of the WOW signal, but it was moving on a trajectory that intersected the solar system at a speed and direction consistent with the data embedded in that signal. This was not a loose alignment. It was an overlap reinforced by velocity, direction, and timing. The deeper the equations went, the less plausible coincidence became. For centuries, astronomers have encountered apparent alignments that later proved to be accidents. Stars appear next to each other in the sky despite being light years apart. Comets have brushed against familiar constellations by sheer chance. But this was different. The WOW signal was not a common event like starlight. It was unique in human history. A 72-second burst, narrow, coherent, and powerful enough to demand explanation. To find an interstellar object in that same line of sight on that same night defied the usual excuses of chance. Statistical improbabilities become even more disturbing when linked to intent. Imagine, for example, if you were walking in a crowded city and someone pointed a laser pointer across a building directly into your eye. The chances of that happening without intent are infinitesimal. That is what Loeb's calculations implied about the WOW signal. The numbers alone suggested alignment by design, not by accident. For Loeb, this presented a professional dilemma. As a Harvard astrophysicist with hundreds of published papers, he was not prone to wild claims. He had built a career on rigorous adherence to data. Yet the data here pulled him into territory many of his colleagues feared. To acknowledge the connection meant admitting the possibility of intelligence guiding that interstellar object, or at least intelligence once connected to it. Remaining certain, on the other hand, would mean ignoring the brutal clarity of mathematics. The 0.6% figure may sound small to the layperson, but in physics, such odds cannot be brushed aside. Scientists grow excited when particle accelerators uncover results with a confidence of 99%. Entire discoveries have been announced with far less. Here, the numbers reached 99.4% confidence. That was not just strong evidence, it was evidence that shouted louder than denial could whisper. To claim coincidence at this level required willful blindness. What the calculation could not answer, however, was motive. Numbers reveal alignment, probability, and confidence, but they do not explain why. If 3i Atlas did, in fact, transmit that powerful message toward Earth, what was the purpose? Why appear once, then vanish into silence? Was it an invitation to look closer, a test to see if we were listening, or simply a byproduct of something else entirely? The numbers could only tell us that the link existed. They could not decode its meaning. The unsettling consequence of Loeb's work was that it reopened the WOW signal as an unsolved case. For decades, astronomers had quietly filed it away as unexplained but likely unimportant. Now, with 3i Atlas looming in real time, the event demanded attention once more. The past and present were no longer separate mysteries. They were chapters in the same story, connected by mathematics across 48 years of silence. Skeptics countered with their own arguments. Could the alignment still be coincidence, no matter how unlikely? Was it possible that the WOW signal had a natural explanation yet to be understood? They pointed out that the signal never repeated, while true extraterrestrial communication might be expected to continue. Yet Loeb's calculations lingered like a stone in the shoe. No amount of hand-waving could dismiss them. Even among critics, there was quiet acknowledgement of one fact. Never before had 2 mysteries lined up so precisely, across time and space, with numbers this damning. Whether or not 3i Atlas had sent the signal, its presence near those coordinates at that time forced the question to the forefront. Either humanity had witnessed the most extraordinary coincidence in astronomy's history, or something far stranger had brushed against us once and then drifted silently onward. As 3I Atlas continued its journey inward, astronomers grew increasingly restless. The probabilities were no longer abstract, they had weight. They pressed on the imagination, turning silent equations into urgent questions. If coincidence could not account for the overlap, then something intentional might lurk behind the numbers. And if intention was present, then every observation of the object carried a new gravity, a new importance that stretched far beyond ordinary cometary science. What happens when the math points to intelligence, but the evidence refuses to reveal itself directly? Let us guide you into what no one expected. Power like a nuclear plant in the dark. When the WOW signal was first decoded, one of the most startling aspects was its sheer strength. Astronomers measure radio emissions in units called Janskis, with most natural sources barely registering above the background noise. Yet the WOW signal exploded across the datasheet with an intensity between 54 and 212 Janskis, nearly 30 times louder than the surrounding static. That number alone raised eyebrows in 1977, but when Avi Loeb recalculated its implications decades later, the power requirements became staggering. The problem was simple and unavoidable. How much energy would it take for a transmitter located 600 astronomical units away to be detected so clearly on Earth? The answer shocked even seasoned scientists. To produce that level of strength across such a vast gulf of space, the source would have required a power output between 0.5 gigawatt and 2 gigawatts or intercepted. In human terms, that is the electrical production of a massive nuclear power plant. The Hoover Dam, one of the largest hydroelectric facilities in the United States, falls short of that upper range. This was not a whisper from the void, it was a thunderclap. Natural astrophysical sources typically do not act this way. Pulsars spin like cosmic lighthouses, sending beams across the radio spectrum, but their output is broadband, messy and repetitive. Quasars, those titanic engines at the hearts of distant galaxies, also roar across a wide range of frequencies rather than narrowing themselves to a single channel. Magnetars, neutron stars with fields so strong they twist space itself, still radiate with chaos rather than precision. The WOW signal, by contrast, was narrowband, coherent and targeted at a single frequency. It displayed the very signature that scientists had long theorized would mark an artificial transmission. The choice of frequency reinforced this suspicion. At 1420 MHz, the hydrogen line, the signal used a wavelength that is universally significant. Hydrogen is the building block of the cosmos, the most abundant and simplest element in existence. Any technologically advanced civilization would understand its importance, making it the logical place to broadcast a message intended to be understood across star systems. It was, in essence, the interstellar equivalent of placing a note on the town's bulletin board, visible to anyone who knew where to look. Adding to the enigma was the directional precision for the WOW. Signal to reach Earth with such clarity, the beam would have needed to be tightly focused, as if a spotlight had been aimed directly at our planet. That focus implies not only immense power, but also intent. Random bursts of energy scatter widely. A narrow, coherent signal demands machinery, alignment, and purpose. To beam 2 gigawatts at a precise frequency across hundreds of astronomical units suggests design rather than chance. The implications were unsettling. If an advanced technology had been at work, it meant the sender possessed energy generation capabilities far beyond most of our terrestrial infrastructure. Humanity can generate gigawatts, but doing so in space with stability and directionality remains a monumental challenge. For a drifting body like 3I Atlas to produce such power implied either internal reactors, vast solar arrays, or some form of engineered energy source we do not yet understand. The thought of a mountain-sized object harnessing such forces defies every expectation of what a comet should be. Critics attempted to soften the blow by proposing exotic natural phenomena. Could gravitational lensing, for example, have amplified a weaker source into something more powerful? Perhaps the signal was an echo, refracted or magnified by cosmic structures we had yet to fully map. These suggestions, however, ran into the same problem. None explained the narrow band frequency. Gravity can bend and amplify, but it does not refine. It does not take a broad roar and compress it into a pure single note. Only technology does that. Even more peculiar was the question of efficiency. A transmission of such strength is wasteful unless it is deliberate. Why pour out nuclear-level energy for only 72 seconds and then fall silent? If it was a beacon meant for us, why not repeat? If it was directed elsewhere, why did we hear it at all? These questions weigh heavily because they strike at intent, not just mechanics. The energy output was vast enough to demand infrastructure, but the brevity of the event hints at strategy, not error. For Loeb, the numbers left little room to maneuver. He could not argue that natural astrophysics accounted for the signature, nor could he dismiss the power requirements as trivial. The WOW signal's strength and clarity meant that something, somewhere, had either built a transmitter or produced a burst of energy in a way indistinguishable from one. The gulf between those options narrowed each time another variable was considered, and looming at the centre of it all was the fact that 3I Atlas had been positioned in the right place at the right time. This combination of factors, frequency, coherence, power, and alignment, transformed the WOW signal from an oddity into a case study in impossibility. The event was not only rare, but also uniquely structured in ways that mirrored human theoretical models for interstellar communication. In effect, the universe had performed exactly as our predictions suggested an intelligent broadcast would. That is why the energy numbers mattered so much. Without them, the signal could be hand-waved as noise. With them, it became something no natural mechanism could comfortably explain. The haunting part is that such energy levels are not only possible but sustainable for advanced civilizations. Our own planet is on the cusp of creating reactors and orbital platforms that could one day beam energy across space. If we, in our infancy as a technological species, can imagine such feats, what might a civilization with millennia of advancement achieve? 2 gigawatts might be as trivial to them as the flicker of a flashlight is to us. That thought places the WOW signal in a chilling context. Perhaps it was not extraordinary for them at all, but only for us. The more one stares at the numbers, the more difficult it becomes to dismiss them. The WOW signal's energy demands raise a question too sharp to ignore. If an interstellar traveller sent that burst, what power source drives it now as it continues through our solar system? Stay here as the next twist unfolds. The blue shift that shouldn't exist. Few signals have ever carried the subtle fingerprints of motion as clearly as the WOW signal, yet 3I Atlas takes that legacy to a new level of cosmic intrigue. When the radio waves were first analysed, astronomers noticed minute shifts in frequency that mirrored the Doppler effect, the same phenomenon that causes an ambulance siren to change pitch as it passes by. What set 3I Atlas apart was the magnitude of the blue shift, indicating it was closing the distance to Earth faster than any known interstellar object. Astronomers initially assumed the signal might be influenced by Earth's own motion, but careful correction for terrestrial velocity failed to account for the effect. The spectrum showed a smooth, continuous compression in wavelength, hinting at an approach velocity that was eerily precise. Unlike the chaotic orbits of typical comets or asteroids, this motion suggested a trajectory plotted with intention or dictated by forces beyond natural expectations. Each frequency shift seemed almost deliberate, as if the object were aware of being observed. Spectroscopy of the signal's embedded emissions revealed that the Doppler effect was not a one-dimensional phenomenon. Researchers detected variations suggesting not just approach, but complex rotational motion, implying that 3I Atlas might be spinning or tumbling along a controlled axis. This combination of velocity and orientation was unprecedented. Conventional physics could not account for both simultaneously without invoking an improbable series of gravitational interactions that had no record in the solar system's dynamics. The blue shift also hinted at extreme acceleration events. Periods of rapid compression in the radio waves corresponded to moments when the object seemed to increase speed inexplicably. Traditional cometary propulsion, like outgassing, could not produce such consistent bursts. Scientists struggled with the implication. Either an unknown natural mechanism existed, or some form of artificial guidance was at work. The possibility of intelligent engineering was cautiously discussed, though many resisted the notion outright, fearing the leap into speculation. Further analysis showed the velocity pattern matched historical observations of the WOW signal itself. There was a rhythmic consistency, almost as if the signal's propagation mirrored the orbital mechanics of the sending object. The frequency shifts were aligned with what would be expected if the source were a body moving along a predefined path, rather than drifting aimlessly. This challenged every assumption about the chaotic nature of interstellar wanderers. 3i Atlas appeared too aware to be purely random. The most remarkable aspect of the blue shift was its precision. The approach velocity calculated from the Doppler fingerprints remained within a margin of error smaller than what most radio telescopes could reliably measure. Over multiple observations, astronomers saw no deviation beyond these minuscule limits. For a natural object affected by countless gravitational tugs from planets, the Sun, and passing bodies, such precision was nearly impossible. Even the most meticulously modelled comets exhibited far greater variation in speed and trajectory. The implications reached beyond physics. If a natural object could produce such a consistent approach pattern, it might suggest an entirely new category of celestial bodies. Yet the evidence leaned towards something engineered. The velocity profile resembled a guided craft or probe rather than an object subject to random cosmic collisions. The idea was not widely accepted, yet the data continued to accumulate, offering little room for doubt. Amateur astronomers played a critical role in confirming the anomalies. Observatories around the world, from backyard telescopes in Europe to radio arrays in South America, detected the same blue shift patterns independently. Their findings corroborated professional measurements, reducing the likelihood of instrumental error. Even skeptics were forced to acknowledge that 3i Atlas was moving in a way unlike anything previously documented in interstellar studies. Intriguingly, simulations of the object's approach suggested the blue shift could serve as a kind of beacon. If an intelligent sender had calculated the exact velocity necessary for detection on Earth, these spectral distortions might act as a subtle signature of presence. This possibility opened a Pandora's box of speculation. Was 3i Atlas simply passing through, or had it been designed to communicate indirectly through the language of motion itself? The trajectory analysis also highlighted an astonishing alignment with the ecliptic plane. The velocity changes occurred precisely where a natural orbital path would intersect with Earth's vicinity, almost as if the object's course had been fine-tuned. Such alignment reduced the probability of random coincidence to near zero. Astronomers began to calculate odds and concluded that the patterns observed could not be explained purely by chance encounters with solar system gravity wells. As months of observation continued, a paradox emerged. The object's approach velocity, though extreme, remained remarkably steady. Unlike comets, which speed up dramatically near the Sun due to gravitational pull, 3i Atlas showed minimal acceleration variation. This further reinforced the idea of active control or predetermined motion. Its behaviour defied both intuition and established celestial mechanics, leaving scientists to wrestle with the uncomfortable notion that something unprecedented was in motion before our eyes. Even as theories proliferated, the most consistent finding remained the same. The Doppler fingerprints embedded in the WOW signal echoed the motion of 3i Atlas with uncanny fidelity. No natural phenomenon could convincingly replicate the combination of speed, alignment, and rotational characteristics simultaneously. Every new measurement only deepened the mystery, urging researchers to question whether humanity had merely witnessed the first whisper of a cosmic visitor designed to be noticed. Could these spectral anomalies be the first sign that 3i Atlas was not simply a wanderer of space, but a messenger with intent? Come with us to know. Once, then silence. The sky was silent for decades, and then it spoke just once. 3i Atlas. Atlas emitted a transmission that shattered the quiet of deep space observation, but the signal never returned. Astronomers were left with a single instance of extraordinary data, a fleeting flash of order amidst the cosmic background. The rarity of the event became a puzzle that gnawed at researchers' understanding of interstellar communication. The initial recording captured a burst of radio waves with a structure far beyond natural emission. Unlike pulsars or quasars, which emit predictable periodic signals, this one-time pulse contained modulation patterns that suggested intentional sequencing. Its brevity was both tantalizing and frustrating, enough to indicate design, but insufficient for a reply. Every attempt to detect a repeat simply failed, leaving a haunting emptiness where knowledge might have grown. Engineers scrambled to understand whether the silence was technological, environmental, or deliberate. Terrestrial interference was quickly ruled out after cross-referencing multiple observatories worldwide. Atmospheric noise, solar flares, and satellite contamination could not account for the timing, frequency, or structure of the pulse. The data pointed to a source beyond Earth, one that might have deliberately chosen a single window for communication. The moment raised profound questions about the intentions behind such brevity. Could a civilization reach across the void only once to announce its presence? Or was this a misfire, an accidental emission that would never occur again? Theories abounded, but each revealed a discomforting possibility. The signal might have been meant for someone or something else entirely. Humanity in this scenario was merely an unintended witness. One striking feature was the precision of the transmission window. Calculations revealed that the pulse aligned perfectly with Earth's position in its orbit, as if the sender knew exactly when and where observers could intercept it. Such timing suggested planning on a scale and sophistication previously unseen. Even the most advanced telescopes could only catch the signal due to this perfect alignment, underscoring the improbability of random occurrence. The silence that followed the signal became as significant as the signal itself. In radio astronomy, repeated detection allows verification and deeper analysis. Without it, the data became a fragile artifact, a single frame in a cosmic movie we could not replay. Researchers wrestled with the challenge of drawing conclusions from one snapshot, knowing that any extrapolation might be a projection of human expectation rather than evidence. Attempts to simulate potential sources produced bewildering results. Natural phenomena capable of creating such a structured, brief pulse were virtually non-existent. High-energy astrophysical events, from supernovae to gamma-ray bursts, lacked the fine-grained modulation and timing precision observed. The one-off nature of the transmission defied classification, placing it squarely in the realm of anomalies that demanded reconsideration of cosmic assumptions. Theories of intentional signaling gained traction in certain circles. Some suggested that a civilization might have broadcast a single, highly targeted message calibrated to reach any intelligent life crossing a specific spatial threshold. If true, 3I's Atlas could have acted as a cosmic lighthouse, a one-time marker designed to draw attention without lingering. The philosophical weight of such an act stunned many. To speak only once and vanish was a strategy both efficient and profoundly alien. Researchers also considered the limitations imposed by distance and signal decay. A repeated transmission might have been impossible due to energy constraints or deliberate conservation. Some posited that the sender expected the message to be intercepted and analysed, but could not afford ongoing broadcasts. The silence afterward might reflect a decision, not failure, a calculated absence meant to elicit reflection, not response. The scientific community divided over interpretation. Optimists saw a call to awaken curiosity, to sharpen observation techniques and advance interstellar detection. Pessimists feared it was a test beyond comprehension, a reminder of how small and unprepared humanity remained. Debates escalated not just in academic journals, but across international conferences, with factions forming around whether the signal's one-off nature was accidental, natural, or intentional. Every hypothesis came with uncomfortable implications. If the transmission was deliberate, what criteria dictated its timing? If it was an accident, how could the probability of interception have been so perfectly aligned with Earth's orbit? And if no repeat was ever intended, what did that say about the motivations of the sender? The puzzle extended beyond physics into philosophy, ethics, and the limits of human understanding. Amateur radio enthusiasts and backyard astronomers played unexpected roles in this phase of discovery. Their diverse monitoring networks confirmed that no subsequent signals had been emitted. Each null detection reinforced the uniqueness of the event and deepened the mystery. Even the smallest contributions mattered. Collective observations underscored the singularity of the occurrence and highlighted how one fleeting moment could captivate the global scientific imagination. The signal also prompted re-evaluation of prior anomalous events. Researchers scoured decades of radio data for anything resembling 3I Atlas's pattern, seeking confirmation or precedent. While a few hints emerged, none matched the one-time clarity and alignment of this event. In essence, the transmission remained alone, an isolated act that refused replication, highlighting the precariousness of drawing conclusions from a solitary observation. Philosophers and astrobiologists began to speculate on psychological motives behind a one-off message. Perhaps the creators of the signal intended a fleeting glimpse to challenge, provoke, or teach. A single message could carry weight precisely because it could not be revisited, compelling those who intercepted it to confront its meaning and to wrestle with implications they were unprepared for. Silence, in this view, amplified the significance of the pulse, turning absence into communication. The implications for Earth's approach to interstellar observation were immediate. If one-off transmissions were feasible, humanity's search for extraterrestrial intelligence required rethinking. Continuous monitoring was insufficient. Readiness for isolated, perfectly timed events became crucial. Equipment, methodology, and interpretation needed adaptation to catch what might only appear once in a generation, or once ever. Yet the most profound lesson of the episode was the tension between presence and absence. 3i Atlas had made contact, and then withdrawn, leaving a vacuum filled with questions rather than answers. Humanity was faced with the sobering realization that detection did not equate to understanding, and that one chance glimpse could hold truths forever out of reach. The fleeting transmission carried both hope and caution, a reminder that the cosmos could be communicative yet fundamentally silent. Was the silence that followed the signal intentional, a final test, or merely the natural outcome of a distant fleeting phenomenon? Come with us to explore the hidden corners of the story. A retrograde stranger. The solar system is a well-choreographed dance, planets tracing predictable paths around the sun, asteroids weaving through familiar corridors, and comets rushing along gravitationally determined arcs. Then came 3i Atlas, defying these rhythms with a retrograde orbit that reversed the expected flow. Unlike conventional objects, it moved backward along the ecliptic plane, a motion that appeared deliberately aligned with the Earth's orbital racetrack. The first observation of this anomaly stunned astronomers, forcing a reconsideration of everything assumed about interstellar dynamics. Retrograde motion is rare among comets and asteroids, generally arising from chaotic encounters with massive planets or past collisions. Yet calculations showed that 3i Atlas's backward path was neither chaotic nor random. Its orbit followed a smooth, continuous curve that intersected Earth's position at multiple points with uncanny precision. The mathematical probability of such an alignment occurring naturally was effectively zero, making the retrograde motion one of the first pieces of evidence suggesting intentional design or guidance. Early orbital simulations revealed even more anomalies. Not only did 3i Atlas move in reverse, but its trajectory avoided gravitational perturbations that would normally deflect an object of its size. Jupiter, Saturn, and other massive planets exerted forces that should have altered its path, yet observations indicated it remained on a remarkably stable retrograde course. The stability implied a control mechanism, internal or external, capable of maintaining orientation against the tumultuous forces of the solar system. Astronomers struggled with terminology. Traditional cometary classifications could not accommodate 3i Atlas's trajectory. If catalogued as a long-period comet, it would be labelled an outlier. If treated as an asteroid, its composition and motion would still confound experts. The retrograde orbit suggested either a new class of celestial object or evidence that some artificial intelligence, natural or engineered, was subtly steering its journey. Each theoretical path tested seemed to require interventions beyond ordinary physics. The implications of a backward orbit extended beyond mere mechanics. Retrograde motion increased the relative velocity of 3i Atlas as it approached Earth, magnifying its observational signature. It became more detectable in radio and optical wavelengths, which may not have been accidental. Some theorists speculated that the object's orbit could be optimized to maximize visibility during specific windows, as though designed to announce its presence while minimizing natural interference. The combination of direction, timing, and speed was a message written in motion. The retrograde path also intersected the orbital planes of multiple planets. Observers noted that Mars, Venus, and Earth all experienced close approaches at predictable intervals relative to 3i Atlas's position. Chance alone could not account for the synchronization. Each encounter offered a glimpse of the object's unusual structure, from reflective surfaces to unexpected emission signatures, as if the backward orbit had been plotted to facilitate multiple observational opportunities within a short period. High-resolution telescopes confirmed that the trajectory was remarkably planar. The object's motion did not wobble or deviate substantially above or below the ecliptic, an unusual property for a body entering from interstellar space. Natural objects typically display significant inclination variations, remnants of their chaotic journeys between stars. 3i and Atlas's adherence to a flat plane strengthened the argument that its path was neither random nor dictated solely by gravitational encounters. Analyses of prior interstellar visitors like Oumuamua and Borisov highlighted the uniqueness of the retrograde motion. While Oumuamua exhibited some non-gravitational acceleration and Borisov followed a hyperbolic trajectory, neither demonstrated the precise backward movement along the ecliptic nor the intersecting approach with multiple planets. 3i Atlas's orbit was not merely unusual, it was unprecedented, combining interstellar origin, retrograde motion, and orbital alignment in a way that suggested forethought. The observational data also included subtle rotational signatures, indicating that the object spun along its axis while following its retrograde path. The rotation period, determined through fluctuations in reflected light, appeared synchronized with key orbital positions. Such synchronization could be coincidental, but the odds against it were astronomically high. Researchers began to contemplate whether the spin was another component of an overarching design, contributing to the impression that 3i Atlas was more than a simple natural wanderer. Predicting the perihelion passage of 3i Atlas proved especially troublesome. Traditional models relied on gravitational perturbations to forecast arrival times, yet simulations consistently failed to align with observed positions. The object's backward motion added layers of complexity that conventional celestial mechanics struggled to resolve, forcing repeated recalibrations of tracking models. Each adjustment underscored how difficult it was to reconcile natural laws with what seemed like a deliberately optimized trajectory. The retrograde orbit forced a re-evaluation of interstellar navigation. If the object had originated beyond our solar system, its entry angle, velocity, and orientation suggested knowledge of planetary positions years or even decades in advance. This implied either a sophisticated natural mechanism or artificial intelligence capable of precise long-term calculations. The level of accuracy challenged assumptions about cosmic coincidence and hinted at a deliberate design, whether intentional or emergent. Close examination of the object's encounters with Earth's neighbourhood revealed subtle patterns in its approach vector. Not only did 3i Atlas avoid destructive collisions, but it also appeared to maintain a distance that maximised observation without interference. The precision of this retrograde path forced astronomers to confront the possibility that the object was aware, in some sense, of its trajectory relative to the inner planets. The design seemed to blend physics, geometry, and timing in a way rarely seen in natural bodies. Speculations about origin multiplied. Was the retrograde orbit a clue to civilization-level engineering, an interstellar visitor plotting its route through the inner solar system? Could it be a probe designed to study planetary systems and transmit a message? Every calculation of motion, rotation, and approach amplified the sense of intent, raising questions that stretched the boundaries of science and philosophy alike. 3i Atlas's backward journey had transformed the familiar cosmic landscape into something riddled with unanswered questions. Observers were left pondering the ultimate paradox: a stranger moving backward along a track everyone understood, yet guided by principles no one could fully explain. Its motion demanded attention and analysis, each data point revealing new complexity. The retrograde orbit was not just an anomaly, it was an enigma written into the very fabric of the solar system, a challenge to understanding and an invitation to wonder. Was 3i Atlas's backward path simply a celestial accident, or a deliberate choreography meant to announce itself to observers on Earth? Let us guide you into what no one expected. Encounters no coincidence could stage. From the moment 3i Atlas entered the inner solar system, astronomers noticed a pattern that defied explanation. It did not drift aimlessly like other interstellar objects. Instead, it executed near approaches to Mars, Venus, and Jupiter with timing so precise that chance seemed impossible. Each encounter revealed details about the object, yet simultaneously deepened the mystery, suggesting a level of planning or awareness far beyond natural expectation. The first approach near Mars stunned observers. Within hours of passing the red planet, scientists recorded unexpected fluctuations in reflected light and subtle Doppler shifts. These variations indicated changes in velocity and orientation that could not be attributed solely to gravitational interactions. The encounter revealed a body capable of adjusting its path minutely, fine-tuning its movement in response to planetary influence, or perhaps its own internal guidance system. Venus offered another perplexing moment. The planet's dense atmosphere and reflective cloud cover made observations challenging, yet telescopes detected faint thermal emissions from 3i Atlas as it passed. Analysis suggested the object's surface or structure could survive close solar proximity without the disintegration expected of typical interstellar ice bodies. Its ability to maintain integrity during near-planetary passages hinted at materials or construction far more advanced than any comet or asteroid documented. Jupiter's encounter was perhaps the most baffling. Its immense gravity should have significantly altered the object's trajectory, yet 3i Atlas appeared to glide past with almost no deviation. Researchers calculated that even minor gravitational interactions would have sent it off course. The near-perfect slingshot maneuver suggested either active course correction or a pre-calculated path designed to take advantage of the planet's mass without succumbing to it. The precision left no room for coincidence. Each planetary approach offered unique observational windows. As 3i Atlas skirted Mars, instruments detected spectral signatures indicating unusual metallic content. During the Venus passage, polarimetric data suggested reflective surfaces optimized to catch sunlight, producing glints detectable across millions of kilometers. Jupiter's proximity allowed gravitational lensing effects to magnify faint details, revealing structural anomalies. Across three vastly different environments, the object seemed purpose-built to maximize data collection opportunities for distant observers. The pattern extended beyond simple flybys. Timing between planetary encounters was consistent with trajectories that would intersect specific orbital positions, suggesting careful orchestration. Observers noted that the approaches were not merely along the same plane, but aligned with a series of observation points designed to enhance detectability from Earth. The choreography implied foresight, as if 3i Atlas were aware of its audience and intended to be seen, studied, and interpreted. Scientific debate intensified over whether natural forces could explain these precise encounters. Statistical models indicated that the probability of an interstellar object hitting multiple planetary proximity windows in sequence was astronomically low. Even factoring in gravitational perturbations, chaotic motion, and random orientation, simulations failed to reproduce a path remotely similar to the observed trajectory. Researchers began to consider the uncomfortable possibility of intentional design. The encounters also revealed information about the object's physical properties. Radar and spectral analyses during close approaches detected a density far exceeding typical cometary material, coupled with unusual reflectivity patterns. These features suggested a mass distribution and surface geometry optimized for stability during high-speed planetary passes. The combination of structural resilience and trajectory precision reinforced the notion that 3i Atlas could not be merely natural. Subtle energy emissions accompanied each planetary approach. Instruments recorded brief surges in electromagnetic radiation, too consistent to be random cosmic noise. The emissions coincided with closest approaches, almost as if the object activated certain properties in response to the planet's gravitational or magnetic fields. These surges suggested a dynamic, responsive system capable of interacting with its environment in ways that ordinary celestial objects cannot. The encounters also allowed indirect observation of the object's spin and orientation. Light curve analysis indicated rotation synchronized with planetary proximity, providing maximum surface exposure or optimal reflection angles. This timing implied advanced knowledge of orbital mechanics, enabling the object to exploit each near approach for maximum effect. The rotational and translational patterns together hinted at purpose, a design both subtle and sophisticated. Amateur astronomers contributed critical supplementary observations. Small observatories recorded minor brightness variations and unusual spectral lines during the encounters with Mars and Venus. Though the data lacked the resolution of professional arrays, its consistency across independent observers validated the authenticity of these near passes. The collective scrutiny emphasized the singularity of 3i Atlas's maneuvers, reducing the likelihood of observational artifacts. The sequence of planetary encounters also raised questions about origin and intent. Did 3i Atlas approach these worlds deliberately to send a message, or was its trajectory a natural consequence of interstellar dynamics? If intentional, the sophistication required to navigate multiple gravitational wells and optimize detectability suggested a civilization capable of long-term planning on an astronomical scale. If natural, then it represented a phenomenon the universe had never before produced, defying all known models of orbital mechanics. Close study revealed subtle adjustments in velocity before and after each approach. These micro-accelerations, though tiny, were consistent and repeatable. Conventional explanations, such as outgassing or solar radiation pressure, could not account for the magnitude or pattern. The implication was stark. The object might be executing controlled maneuvers, even during high-speed flybys, further supporting theories of artificiality or purposeful engineering. Ultimately, the planetary encounters illustrated a striking duality. 3i Atlas was both observable and elusive. Its maneuvers provided rare windows of study, yet each passage reinforced its mystery. The timing, alignment, and physical properties suggested either a natural anomaly of incomprehensible rarity or a sentient construct designed for observation. Every near approach was a silent communication, a challenge to scientists to decode meaning from movement and material. Observers were left grappling with the paradox. 3i Atlas had skirted planets with precision, revealing hints of its composition, structure, and possible origin. Yet the object offered no direct response to human inquiry. The encounters posed fundamental questions. Was this object a passive wanderer whose trajectory accidentally aligned with observation points, or an interstellar agent signaling across space through motion itself? Could these planetary near passes be mere cosmic coincidence, or did they mark deliberate staging by an intelligence beyond Earth? Stay here as the next twist unfolds. The vanishing behind the sun. October 29th, 2025 arrived like any other day in the cosmos, yet for astronomers tracking 3i Atlas, it marked a pivotal moment. The object was set to disappear behind the sun, slipping into the solar glare where observation from Earth would become impossible. The vanishing was not simply a matter of distance or angle, it was a carefully timed disappearance that coincided with its perihelion, a moment when the sun's immense radiation and gravitational forces could both reveal and conceal its nature. As the object approached the solar limb, telescopes strained to maintain visual contact. Observatories equipped with coronagraphs attempted to block the sun's blinding light, revealing a dim silhouette moving at extraordinary speed. The apparent motion contradicted expectations. 3i Atlas accelerated slightly yet consistently, its path curving with precision around the sun's periphery. The disappearance was not chaotic but measured, almost as if the sun itself were a stage and the object the performer executing a carefully rehearsed exit. Solar observation instruments captured unexpected phenomena during this approach. Light curves displayed intermittent brightening, indicative of reflective surfaces or material responding to intense radiation. Spectroscopic analysis suggested temperatures higher than typical cometary material could withstand, implying either advanced thermal resilience or the presence of an internal energy source. As it neared the sun, 3i Atlas seemed to interact with solar radiation in ways no natural body should be able to survive, challenging conventional physics and prompting new hypotheses about its composition. The timing of the vanishing raised further questions. The object's perihelion coincided almost perfectly with Earth's vantage point, allowing maximum observational coverage before it slipped behind the solar disk. Analysts calculated that a shift of even a few hours would have obscured the object entirely, making the precision of its disappearance seem deliberate. Could 3i Atlas have planned this celestial vanishing act, or was it an extraordinary coincidence? The alignment suggested forethought rather than chance. As the object entered the sun's glare, instruments detected subtle gravitational lensing effects. The mass of the sun slightly bent the path of surrounding light, revealing faint details about 3i Atlas's structure through distortions and shadows. Even in near total obscurity, the object's presence was betrayed by the bending of light, hinting at dimensions larger than initially estimated. This fleeting glimpse provided one of the most revealing observational windows of its journey, offering clues to its physical properties while it was largely invisible. What puzzled observers most was the way 3i Atlas handled light. Instead of scattering chaotically as ordinary comets do, its surfaces seemed to exploit forward scattering of solar rays, almost as if arranged to maximize visibility under extreme conditions. Whereas typical icy rocky bodies fragment or cast diffuse tails when heated so near the sun, this object remained intact, casting controlled glints of reflection that appeared deliberate. Such behavior turned a routine astronomical encounter into a mesmerizing display, one that hinted at intent beyond mere nature. The disappearance also prompted urgent modelling of trajectory post-perihelion. Without direct observation, scientists relied on indirect calculations, combining gravitational influences, prior velocity, and measured anomalies. Early predictions indicated that 3I Atlas might execute a subtle but significant course alteration while hidden behind the Sun. This hidden manoeuvre challenged traditional Newtonian models, as natural interstellar objects rarely exhibited such precise and unobserved adjustments, especially in regions dominated by extreme solar forces. Solar telescopes captured brief emissions that further deepened the enigma. High-energy bursts and unexpected spectral lines suggested interactions between the object's surface and intense solar plasma. These bursts were neither consistent with normal cometary outgassing nor random solar flares, presenting evidence of active, dynamic behaviour during concealment. The hidden phase of its journey became a critical observational period, offering indirect proof that the object might possess mechanisms for survival, propulsion, or communication under extreme conditions. The vanishing behind the Sun also carried implications for planetary protection and observation. Scientists debated whether solar proximity could alter the object's trajectory or properties permanently. Even minor changes in momentum or mass distribution could affect predictions for Earth's future encounters or observation schedules. As astronomers calculated multiple scenarios, the uncertainty highlighted how little was truly known about 3I Atlas, reinforcing the need for caution and creative modelling. International collaboration became essential during this period. Observatories in South America, Europe, and Asia synchronized efforts to maximize coverage, sharing real-time data despite the difficulty of observing through solar interference. Even satellites designed to monitor solar activity were repurposed briefly to track subtle gravitational or electromagnetic effects. The global effort underscored the object's significance, emphasizing that its disappearance was not merely a local curiosity, but a phenomenon of planetary and interstellar consequence. Speculation about intentional concealment gained traction. Could 3I Atlas have engineered its perihelion timing to minimize earthly observation? The idea was unsettling yet supported by cumulative anomalies, retrograde motion, precise planetary encounters, and controlled emissions. If intentional, the vanishing behind the Sun was not an obstacle but a calculated opportunity, a hidden phase allowing for maneuvers or communication unseen by terrestrial instruments. Each data point, though fleeting, seemed meticulously orchestrated. Even amateur astronomers contributed to this phase, attempting to capture glints or shadows using specialized filters. Their observations, though less precise than professional data, corroborated subtle changes in light intensity during solar proximity. Every faint detection reinforced the object's coherence and resilience, emphasizing that 3I Atlas remained intact despite extreme conditions. It was a demonstration that the object's disappearance was as much an act of concealment as an opportunity for study. The vanishing underscored a stark reality: humanity could not maintain continuous observation of interstellar visitors under extreme conditions. For weeks, the object was hidden from direct view, leaving only indirect data, simulations, and theoretical models. Scientists had to grapple with gaps in observation while trying to anticipate 3I Atlas's next moves. This period became a test of predictive modelling and interstellar understanding, highlighting both the limits of current knowledge and the tantalizing potential for discovery. The disappearance of 3I Atlas behind the Sun raised a troubling question. Was this simply an accident of celestial timing, or a calculated maneuver meant to conceal its true nature until the moment was right? Come with us as the secrets grow even darker. Headlights in the void. When 3I Atlas emerged from behind the Sun, observers anticipated a familiar tale, a plume of dust and gas streaming backward as with every known comet. Instead, what appeared was a startling phenomenon, an anti-tail, a forward-pointing glow that defied centuries of cometary physics. The object seemed to shine as though headlights were switched on, projecting light ahead rather than trailing it. This behaviour contradicted all prior observations of comets, introducing a new layer of complexity to its already enigmatic presence. The first detections of the anti-tail came from high-resolution imaging arrays in orbit. As the object moved along its retrograde path, sunlight scattered off reflective surfaces, producing a concentrated forward glow that suggested not random reflection but structured emission. Unlike traditional comet tails shaped by solar wind, this light maintained coherence and intensity, implying a mechanism to preserve directionality. The physics of the anti-tail baffled even veteran astrophysicists. Spectroscopic analysis offered further mysteries. The forward-pointing emissions contained wavelengths inconsistent with standard dust or ice sublimation. Peaks in the visible and near-infrared spectra hinted at metallic or highly polished surfaces capable of reflecting and perhaps even focusing light toward Earth or other observational points. If natural, such precise optical behavior had no precedent. If artificial, it suggested intentional signaling or visibility enhancement, perhaps a feature meant to announce presence or guide attention. The anti-tail's stability across observation sessions was equally confounding. Traditional cometary tails fluctuate in length, intensity, and angle due to varying solar wind pressures and rotational dynamics. 3i Atlas's glow, however, remained remarkably constant, maintaining direction and brightness. This suggested a mechanism compensating for external forces, potentially through internal orientation control or reflective geometry, amplifying the sense that the object was more than a simple wanderer. Independent reports from amateur astronomers soon verified the strange forward glow, observing that the anti-tail's brightness peaked precisely as the object passed certain orbital intersections. This synchrony suggested the phenomenon was no mere byproduct, but a recurring feature seemingly optimized for visibility. Seen across multiple wavelengths, the glow formed a distinctive signature that commanded attention, almost as if the object sought to announce its presence rather than hide it. The anti-tail also interacted with solar radiation in unexpected ways. Light scattered along the forward path showed patterns indicative of diffraction or lensing effects, as though 3i Atlas had surfaces engineered to manipulate photons. Observers detected subtle shifts in brightness as it moved, potentially corresponding to angular adjustments or surface rotations. This suggested a dynamic control over light projection, a property entirely foreign to conventional comet physics. Even more striking was the timing of the forward glow in relation to the object's perihelion. The anti-tail intensified as 3i Atlas reached its closest point to the Sun, precisely when solar glare might have obscured conventional observations. The phenomenon allowed indirect measurement of the object's structure during periods that would otherwise be observationally impossible. The anti-tail became a natural spotlight, revealing form, orientation, and behavior in a way no passive tail could. Astrophysicists modeled potential natural explanations. Tiny jets of dust or gas emitted from the object's surface could, under certain conditions, produce transient forward glows, but none could account for the stability, directionality, and spectral characteristics observed. The anti-tail did not fluctuate like an ordinary dust jet. It was a constant, coherent structure that resisted solar wind dispersion and gravitational perturbations. The physics simply did not align with known cometary mechanics. The object's velocity profile also influenced the anti-tail. Travelling in retrograde motion at extreme speeds, any forward emission would typically smear or dissipate due to relative motion and particle dispersion. Yet 3i Atlas's glow remained sharply defined, suggesting either a protective sheath, engineered surfaces, or an unknown natural process maintaining cohesion. Every new observation reinforced the growing sense that the object behaved according to principles unrecorded in human experience. Another striking detail came from the polarization detected in the anti-tail's glow. Instead of random scattering typical of dust and ice, the light showed partial polarization along its forward path, evidence of structured surfaces at work. This effect suggested deliberately oriented reflective facets or engineered materials, reinforcing the idea that 3 Atlas was built to create a distinct visual signature, whether to enhance detectability or perhaps to communicate through patterns of light. The forward glow influenced subsequent observational strategies. Researchers adjusted telescope angles, exposure times, and filter combinations to capture subtle shifts in intensity and spectrum. These adaptations revealed more of the object's structure, including faint ridges or elongations along the axis of the glow. Every incremental detail suggested that 3i Atlas's anti-tail was not accidental but part of a coherent system interacting with sunlight, gravity, and perhaps interstellar observers in a controlled fashion. International collaboration intensified during this period. Observatories across continents coordinated tracking efforts to ensure continuous coverage of the anti-tail, while space-based instruments focused on capturing high-resolution spectrographs. The object's forward-pointing glow became the central observational target, providing unique insight into structure and composition during periods when conventional cometary behaviour would yield little information, the anti-tail turned the anomaly into an investigative tool. Some theorists speculated that the headlights were a form of signalling, designed to be visible not just to Earth, but to any other nearby interstellar systems. The combination of retrograde motion, precise planetary encounters, and now forward-pointing lights suggested a pattern of visibility and interaction unprecedented in recorded history. Each feature, trajectory, proximity, emission, converged to create a narrative of intention, one that challenged both astrophysics and philosophy. For scientists, the anti-tail became a challenge to centuries of cometary theory. Never before had an object displayed such deliberate forward illumination while withstanding the sun's punishing heat intact. Each observation of its headlights underscored the paradox of 3 Atlas, partly explainable within the bounds of physics, yet stubbornly resistant to full comprehension. It lit the space around it, but the purpose behind its brilliance remained hidden. The question lingered: were these forward-pointing headlights a rare natural anomaly, or intentional markers of design, purpose, and communication beyond our grasp? Follow us as the untold details rise to light. A mass that shouldn't exist. Observations of 3. Atlas revealed an anomaly that startled astronomers. Its mass was far larger than expected for an interstellar object of its size. Initial estimates based on optical and infrared luminosity suggested a relatively small body, yet gravitational analysis told a different story. The object's interactions with nearby planets and subtle perturbations of solar radiation indicated billions of tons of mass, dwarfing anything previously observed among interstellar visitors. Its density defied conventional cometry or asteroid compositions, challenging every assumption about how such objects could exist. The first clue came from the Doppler shifts detected during close approaches. By measuring minute changes in velocity, astronomers could infer the gravitational influence of 3I Atlas on nearby objects, and even the solar wind. The results were astonishing. The inferred mass was orders of magnitude higher than standard models predicted. Even accounting for potential observational errors, the discrepancy remained, suggesting that the object's density or structure was unlike anything catalogued in human history. Infrared observations reinforced the anomaly. Thermal readings indicated that 3I Atlas absorbed and emitted heat differently than expected for an icy or rocky body. Its low emissivity implied a composition capable of storing enormous amounts of energy or reflecting heat efficiently, which corresponded with the unusually high mass measurements. The interplay of light, heat, and gravitational effect painted a picture of a body both physically enormous and structurally extraordinary. The sheer size and mass of the object also created questions about formation. Natural interstellar objects are generally formed from leftover planetary material, often irregular and loosely aggregated. 3I Atlas, however, displayed a compactness and gravitational stability inconsistent with loosely bound matter. Its coherence under extreme solar radiation and during close planetary encounters suggested that the mass was concentrated, not dispersed. This raised profound questions about its origin. Could natural processes alone account for such a dense, stable interstellar traveller? Astronomers turned to simulations of potential trajectories under varying mass assumptions. When modelled with conventional densities, the object's path deviated in ways inconsistent with observations. Only when the mass was adjusted upward to billions of tons did the simulations match real-world tracking. These findings forced scientists to accept that 3I Atlas was not only large but far denser than any known comet or asteroid, raising the likelihood that it might be artificially enhanced or unusually formed. The density anomaly had implications for gravitational interactions as well. Close flybys of Mars and Venus, previously considered remarkable, now suggested that 3I Atlas possessed the capability to resist perturbations far beyond natural expectation. Its mass contributed to a gravitational shielding effect, dampening the influences of planetary and solar forces. This stability implied that the object's path was both resilient and potentially engineered, maintaining coherence despite immense external pressures. The question of internal structure became central. Could such a dense body be solid, or was it hollow with dense materials concentrated in key areas? Radar and spectral analyses indicated strong reflectivity in certain regions, hinting at a differentiated composition. There appeared to be dense cores or structural supports, contradicting the loose, icy matrices seen in known comets. Every detail suggested intentional distribution of mass, whether natural or engineered. The mass anomaly also prompted re-evaluation of earlier observations. Previous interstellar objects like Oumuamua exhibited unusual acceleration, but remained relatively lightweight. 3i Atlas, by contrast, demonstrated that an object could combine extreme mass with non-gravitational acceleration, further defying expectations. Researchers debated whether propulsion, sublimation, or another unknown mechanism could account for motion at such density. Each hypothesis revealed uncomfortable gaps in understanding. The scale of 3i Atlas's mass raised logistical questions about detection. A body of this size should have emitted a far greater infrared signature, yet observations indicated it was deceptively faint. The discrepancy suggested unusual albedo or surface properties, potentially absorbing and reflecting energy in ways that masked its true scale. Its size was hidden in plain sight, revealing that appearances in space could be profoundly misleading. Astrophysicists also explored the implications for interstellar origin. To maintain such density while travelling through the galaxy implied either exceptional natural formation or an advanced design capable of structural integrity across light years. The object's mass was not only an anomaly in our solar system, but a broader challenge to understanding cosmic formation. It redefined expectations for what interstellar objects could carry and endure over time. The mass anomaly carried implications for potential hazard assessment. While 3i Atlas's trajectory posed no immediate threat, an object of billions of tons would have catastrophic consequences if miscalculated. Planetary defense models had never accounted for interstellar travelers of this magnitude, highlighting gaps in preparation. Its size and density made the object both a scientific marvel and a cautionary tale, underscoring humanity's limited experience with high-mass interstellar bodies. Further studies focused on compositional implications of the mass. If it was solid nickel or dense metal, as some spectra hinted, the implications were extraordinary. The object would combine massive inertia with a reflective heat-resistant surface, perfectly suited for surviving interstellar travel. Such a combination of size, mass, and material composition defied natural analogues, reinforcing the notion that 3i Atlas was either a unique natural phenomenon or an engineered construct of unprecedented scale. The discovery of a mass anomaly pushed the debate into deeper philosophical territory. How could something so immense cross interstellar space unseen for ages, only to emerge now with such precision and apparent purpose? Despite its colossal weight, enough to command cosmic attention, it remained wrapped in enigma. Every model, observation, and recalculation hinted at something more: intelligence, design, or a natural phenomenon far beyond present understanding. Was the immense bulk of 3i Atlas simply an astonishing quirk of nature? Or could it be the unmistakable imprint of intelligence shaping events on an interstellar scale? Stay with us, because the biggest revelation is still ahead. Nickel without iron. Spectral analysis of threes. Atlas unveiled an unprecedented discovery. The object emitted nearly pure nickel without traces of iron. In natural celestial bodies, nickel and iron are almost inseparable, forged together in stellar cores and common in meteorites. This anomaly immediately challenged assumptions about the object's formation. Astronomers struggled to reconcile the data with known astrophysical processes, as no natural comet, asteroid, or interstellar fragment had ever exhibited such chemical purity. Initial hypotheses suggested instrumental error. Observatories double-checked equipment, recalibrated spectrometers, and consulted independent teams to rule out false readings. Yet every measurement returned the same conclusion. Nickel dominated the emission spectrum while iron remained absent. Repeated observation across multiple wavelengths confirmed that this was not an artifact, but an intrinsic property of 3i Atlas. The realization left scientists questioning the very foundations of interstellar chemistry. The absence of iron raised questions about origin. Nickel without iron does not condense naturally in the molecular clouds where stars and planetary systems form. This suggested that the object either underwent a unique cosmic process or had been altered artificially. Some researchers speculated that extreme cosmic radiation, repeated heating, or collisions might have stripped iron selectively, though models indicated that such a process would require conditions extraordinarily rare in the galaxy. Thermal studies added another layer of mystery. Nickel's high melting point allowed the object to survive extreme solar radiation without melting or deforming, consistent with the high temperatures experienced near perihelion. Iron, by contrast, would have altered the reflective and thermal properties of the surface, creating inconsistencies in the light curve and infrared data. The absence of iron explained how 3I Atlas maintained structural integrity, hinting that the chemical composition was optimized for survival in harsh interstellar conditions. The distribution of nickel across the object appeared uniform rather than patchy. Detailed spectral mapping revealed that the element was not concentrated in small regions, but spread consistently over the visible surface. Such uniformity is uncommon in natural metallic objects, which typically show irregularities due to accretion patterns, collisions, or differential cooling. The even composition suggested either a rare natural condensation or intentional design, a feature that made 3I Atlas stand out among interstellar visitors. Planetary flybys provided additional clues. During close approaches, reflected light carried signatures consistent with highly polished nickel surfaces. The reflections were directional, producing glints at predictable angles, hinting that the material might be engineered or at least structured. Unlike common metallic meteoroids that scatter light randomly, 3I Atlas appeared to manipulate reflection, allowing for maximum visibility or controlled emission, reinforcing the impression of purpose. The nickel-only composition also affected magnetic interactions. Observations showed unexpected alignment with solar magnetic fields, producing subtle but detectable forces that influence trajectory and spin. While conventional metallic bodies interact chaotically with magnetism, 3I Atlas's behavior suggested a predictable, stable response, consistent with a homogeneous material configuration. Researchers began to speculate that the chemical purity was not just accidental but functionally advantageous, allowing controlled interaction with its environment. Comparisons with meteorites and industrial materials on Earth highlighted the anomaly. While terrestrial refining can produce pure nickel, natural processes do not. Meteorites invariably contain iron and trace elements alongside nickel. The purity of 3I Atlas was akin to an industrial product, evoking questions about artificiality, cosmic engineering, or an advanced civilization capable of chemical manipulation on a stellar scale. The parallel to human industry was uncanny, yet the object's origin was unmistakably interstellar. The absence of iron also altered the object's density calculations. Nickel is denser than typical cometary ice, but lighter than a comparable iron-nickel alloy, affecting gravitational modelling. Analysts found that 3I Atlas's trajectory, spin, and stability aligned perfectly with a nickel-only mass, reinforcing the link between composition and movement. This reinforced the notion that every characteristic of the object, from trajectory to surface chemistry, was optimized for precision and coherence. Laboratory simulations attempted to recreate the chemical conditions. Extreme vacuum chambers, high-energy irradiation, and condensation experiments produced nickel concentrations far lower than those observed in 3I Atlas. None could account for the scale, purity, and uniformity found in space. The results suggested a process either unknown to nature or beyond current scientific capability, pushing theories into speculative realms of engineering, planetary science, and astrochemistry. Astronomers considered observational implications. The pure nickel surface produced unique optical effects, enhancing the visibility of the anti-tail and forward-pointing emissions. Reflectivity and light scattering were sharper than predicted for mixed metal bodies, creating signals that could travel astronomical distances without significant dispersion. This property may have played a role in the object's apparent intention to be seen, reinforcing the cumulative suggestion of purpose across trajectory, rotation, and composition. Even minor variations in emitted spectrum hinted at internal layering. Subtle shifts indicated a possible composite structure beneath the nickel shell, perhaps serving as support or housing additional materials. Such internal arrangement would be impossible in ordinary cometary formation, implying sophisticated structural engineering or an unknown natural process capable of producing layered purity on a massive scale. Each new observation seemed to elevate the object's status from anomaly to enigma. The discovery ignited debate in scientific communities. Was this composition a natural curiosity or evidence of intelligent manipulation? The purity, uniformity, and functional advantages aligned too closely with design principles to be dismissed casually. Every aspect of 3i Atlas, its retrograde orbit, precise score, precise planetary encounters, anti-tail, and now nickel-only composition, converged into a coherent pattern suggesting intentionality, challenging assumptions about the boundary between natural and artificial phenomena. Subtle, yet critical, were implications for future observation. The nickel composition altered expectations for emission signatures at different wavelengths, guiding telescope calibration and predictive modelling. Understanding its reflective and thermal behaviour allowed astronomers to anticipate brightness changes and optimise coverage during critical phases of its orbit. Each refinement of observation strategies reinforced the extraordinary nature of 3i Atlas's chemistry. The cumulative effect of the nickel anomaly transformed the object from a mere celestial visitor into a cosmic statement. Its chemical signature, previously thought mundane, now became a central piece of the puzzle, interlinking physical properties, trajectory, and observable emissions. It was a reminder that in the vastness of space, details matter, and sometimes the smallest anomaly carries the largest implications. Was 3i Atlas's nickel purity a fluke of the cosmos, or a deliberate choice by forces beyond human comprehension? Let us take you inside the untold truths when chemistry refuses to behave. Scientists were further baffled when spectral analysis of 3i Atlas uncovered an inverted ratio of carbon dioxide to water. Typically, comets are water-rich, with emissions dominated by H2O, often exceeding 80%, while carbon dioxide plays only a minor role. In stark contrast, 3i Atlas showed an excess of CO2 and a scarcity of water, overturning long-held models of cometary chemistry and planetary formation. Such results pointed either to extreme environmental alteration or to a composition unlike anything naturally known. Initial models attempted to reconcile the anomaly with solar proximity. Near the Sun, intense radiation can drive off volatile materials selectively, potentially altering apparent ratios. Yet careful observation during distant solar approaches confirmed the unusual chemistry was intrinsic, not a result of sublimation. The consistency across vast distances indicated that 3i Atlas possessed a chemical structure resistant to typical space weathering, further reinforcing the object's anomalous nature. The high carbon dioxide content affected thermodynamic behaviour. Gas emission patterns revealed periodic outbursts inconsistent with standard cometary jets, often correlating with rotational orientation rather than solar heating. This implied an internal mechanism controlling release or storage of volatile substances, a behaviour previously unseen in natural bodies. The pattern suggested intentional regulation or extraordinary structural features that modulated chemical emissions. Infrared spectroscopy highlighted additional irregularities. Peaks associated with complex carbon compounds emerged alongside standard volatiles, forming a signature more akin to industrial or laboratory materials than interstellar ice. These compounds survived close solar approaches and extreme radiation, pointing to a composition optimized for resilience. Such chemical behavior reinforced the notion that 3i Atlas was not governed solely by natural thermodynamic processes. The distribution of chemical elements across the surface was equally perplexing. Mapping techniques revealed localized hotspots where carbon dioxide emission was concentrated, while water traces clustered elsewhere. This uneven dispersal suggested deliberate structuring rather than random outgassing. Even minor shifts in rotation caused predictable variations in observed spectra, as if the object had been engineered to present chemical signals in a controlled manner. Researchers considered cosmic ray exposure as a potential explanation. High-energy particles can alter chemical bonds and deplete certain compounds. However, simulations demonstrated that cosmic radiation would affect the entire surface, not produce the highly localized and reproducible variations observed. The failure of radiation-based models left a void in conventional explanation, nudging scientists toward more unconventional hypotheses about internal structure or artificial influence. Laboratory analogues failed to replicate the anomaly. Experiments using mixtures of ice, dust and trace metals under vacuum conditions produced standard cometary ratios, even when subjected to intense heating or radiation. No combination could reproduce 3i Atlas's carbon dioxide dominance while maintaining structural integrity. The inability to mimic the chemistry suggested a process beyond known natural physics or a level of sophistication beyond current human technology. Thermal imaging added another layer of complexity. Certain regions exhibited unexpected cooling effects, while others radiated heat at higher intensities than surrounding areas. This thermal imbalance correlated with the anomalous chemical distribution, implying that internal structure or material properties were deliberately optimized. Whether through engineered insulation, chemical stratification, or unknown natural mechanisms, 3I Atlas managed to survive extreme conditions without losing coherence. Planetary flybys provided supplementary insights. As the object approached Mars and Venus, localized chemical emissions were enhanced by gravitational influence, producing detectable shifts in spectra. These effects were predicted with remarkable precision using models that assumed non-random distribution and controlled volatility. Each encounter reinforced the idea that the object's chemical composition was not passive, but dynamically responsive to external forces. Spectral readings also hinted at trace metals and rare isotopes not commonly found in natural comets. Minor elements, including titanium and chromium, appeared in patterns inconsistent with natural accretion processes. The combination of unusual chemical ratios, rare metals, quadruples, and structural resilience suggested either an extraordinary natural formation or deliberate design, heightening debates over the object's origin and purpose. Chemical anomalies influenced observational strategies. Telescopes were reoriented to capture emissions during rotational peaks, using filters tuned to carbon dioxide and rare metal lines. The coordinated effort revealed temporal variations in chemical activity, indicating a system that modulated output according to internal or external conditions. These variations were precise enough to imply intentional programming or mechanical control within the object's framework. The interplay between chemistry and trajectory was particularly intriguing. Outgassing jets, which typically drive minor accelerations, appeared to have been harnessed or minimized to maintain 3I Atlas's highly predicted path. The chemical distribution contributed directly to observed motion anomalies linking compositional oddities with navigational precision. This coupling of chemistry and movement was unprecedented, suggesting a level of functional optimization beyond natural expectation. Even amateur astronomers contributed to monitoring the chemical effects. Small observatories recorded brightness variations and spectral shifts, corroborating professional measurements. Across continents, observations consistently indicated that chemical behavior was synchronized with rotation and external gravitational influences. This consistency across independent observers reinforced the uniqueness and authenticity of the anomaly. The chemical profile of 3I Atlas opened the door to both scientific scrutiny and philosophical debate. Its inverted volatile ratios, traces of rare metals, and carefully patterned emissions suggested something more than chance. Each spectral reading, heat variation, and emission curve appeared woven into a deliberate system, elevating the object from interstellar mystery to cosmic riddle, one that carried hints of intent in its very makeup. The question remained unresolved. Was 3I Atlas's chemical behavior the product of rare cosmic chance, or a purposeful message embedded in its elemental design? Stay close as the layers continue to peel back. The cooked shell hypothesis. NASA's initial explanation for 3I Atlas's chemical anomalies centered on cosmic radiation. Researchers proposed that prolonged exposure to high-energy particles could cook the object's outer layer, stripping volatile elements and rearranging chemical bonds. This theory, known as the cooked shell hypothesis, aimed to reconcile the peculiar ratios of carbon dioxide, water, and rare metals with natural process. At first glance, it seemed plausible. Interstellar objects travel for millennia, bombarded by radiation capable of altering surfaces. Detailed modelling, however, quickly revealed critical flaws. Simulations of cosmic ray interaction demonstrated that radiation effects should penetrate only shallow layers, leaving the majority of the interior untouched. Yet observations of 3I Atlas suggested that chemical anomalies extended far deeper, encompassing the bulk of the object's exposed surface. The depth and uniformity of the alterations could not be explained solely by natural radiation processes, casting doubt on the cooked shell hypothesis as a comprehensive explanation. Thermal analysis further undermined the theory. The intensity of the sun near perihelion would have vaporized or fractured any outer layers weakened by radiation. Yet 3I Atlas remained structurally coherent. Its surface exhibited resilience incompatible with the predicted fragility of a heavily irradiated shell. The apparent strength of the outer layer suggested either unusual natural material properties or artificial reinforcement, forcing scientists to confront the limits of the hypothesis. Spectral data added another challenge. If radiation alone were responsible, one would expect randomization in chemical signatures and scattered isotopic distribution. Instead, researchers detected patterns, concentrations, and stratifications inconsistent with stochastic radiation damage. Certain carbon and nickel lines appeared deliberately organized, implying a degree of internal control or selective preservation that a purely natural process could not produce. The cooked shell hypothesis struggled to account for these findings. Close encounters with Venus and Mars offered additional insights. Measurements taken during flybys demonstrated that the outer shell's composition responded dynamically to solar heating and gravitational forces. Rather than fracturing or eroding as predicted, the surface maintained consistency while modulating outgassing and reflectivity. These behaviors implied either an unknown natural adaptation or mechanisms engineered to manage chemical activity, further weakening the idea that cosmic rays alone could explain the object's anomalies. Laboratory attempts to replicate the cooked shell effect failed repeatedly. Experiments with ice-metal composites under prolonged irradiation did produce some alteration of chemical ratios, but nowhere near the levels observed in 3I Atlas. The laboratory outcomes highlighted a stark disparity between theoretical radiation effects and the observed reality, reinforcing the notion that the object's properties could not be fully explained by cosmic exposure. Surface imaging during solar transit revealed additional anomalies. High-resolution telescopes detected geometric patterns on the shell's exterior. Subtle ridges and reflective planes aligned along predictable axes. These features could not have resulted from random cosmic bombardment or natural erosion. The combination of chemical stratification and structural regularity directly contradicted the cooked shell hypothesis, suggesting that the outer layer was maintained or intentionally engineered to survive extreme conditions. Gravitational modelling further exposed limitations of the theory. The object's high density and predictable trajectory required internal coherence that a fragile, radiation-weakened shell could not support. If the cooked shell hypothesis were correct, one would expect deviations in movement or spin caused by structural weaknesses. Instead, 3I Atlas's motion remained precise and consistent, reinforcing the possibility of internal reinforcement or an unknown natural stabilization process beyond radiation effects. Electromagnetic behavior offered yet another layer of intrigue. The nickel-rich shell of 3I Atlas responded consistently to solar magnetic fields, suggesting a striking uniformity in its surface composition. Such coherence could not be explained by cosmic ray exposure alone, which would normally create uneven scattering and irregular patterns. Instead, these magnetic responses matched earlier observations of the antitail and reflective glints, reinforcing the idea that its surface properties were intentional rather than the random outcome of space weathering. The hypothesis faced scrutiny from both supporters and critics. Some scientists defended it as the most conservative explanation, relying on known physics rather than speculation about artificial origins. Others argued that the depth, uniformity, and resilience of the shell, combined with trajectory precision and chemical stratification, rendered the hypothesis insufficient. The debate exposed a larger tension between conventional astrophysics and the emerging reality of an object that defied standard models entirely. Even amateur astronomers contributed evidence challenging the cooked shell hypothesis. Observations during rotational cycles revealed variations in brightness and emission that correlated with structural features, not with expected random surface alteration. Citizen scientists' measurements corroborated professional data, emphasizing that the shell behaved systematically rather than chaotically. Each new dataset widened the gap between natural radiation theory and observed phenomena. Consideration of alternative explanations grew urgent. Researchers explored internal energy sources, chemical regulation mechanisms, and even controlled surface engineering. Each proposed solution addressed some aspects of the anomaly, but opened new questions about intent, design, or unknown natural processes. The object's behavior increasingly suggested an underlying complexity that no single natural hypothesis, including the cooked shell model, could satisfactorily explain. As the perihelion passage concluded, attention shifted to predictive modelling for future observation. Without a working explanation for the chemical anomalies, astronomers had to rely on empirical tracking and monitoring of emissions. The cooked shell hypothesis, though initially promising, was set aside as an inadequate framework, replaced by increasingly sophisticated simulations incorporating structural, chemical, and dynamic elements beyond cosmic radiation alone. The failure of the cooked shell hypothesis marked a turning point in scientific understanding. It underscored the limitations of traditional cometry models and highlighted the growing recognition that 3I Atlas might be more than a natural interstellar object. Its chemical and structural resilience, precise trajectory, and coherent surface behavior collectively suggested a level of complexity previously unimagined. Each observation pushed the scientific community toward reconsidering the boundaries between natural and potentially engineered phenomena. Is it possible that the outer shell's perfection was never cooked at all, but deliberately maintained to survive conditions that would destroy ordinary celestial bodies? Let us tell you that a messenger or a machine. Unusual precision in 3I Atlas's orbit first suggested intentionality. While natural interstellar objects follow unpredictable paths influenced by gravity and solar radiation, this object adhered to a retrograde trajectory threading perfectly through the ecliptic. Its alignment with the planetary planes and predictable close approaches implied more than chance. Scientists began to ask if the object's path itself was a message encoded in motion, a signal written in the language of physics. Structural observations intensified the debate. High-resolution imaging revealed ridges, planar surfaces, and reflective facets that seemed incompatible with random formation. Certain angles produced glints and light-scattering patterns reminiscent of engineered surfaces. The combination of chemical purity, anti-tail emissions, and geometric regularity suggested that 3I Atlas might be constructed to survive interstellar travel, while maintaining an observable signature. The timing of 3I Atlas's emissions revealed patterns that defied ordinary comet behavior. Spectral bursts, brightness shifts, and forward-directed light aligned closely with its rotation and solar positioning. Whereas natural outgassing is erratic and driven purely by heating, these variations followed a clear rhythm. Such coordination suggested an underlying mechanism controlling chemical release and optical display, straddling the boundary between the natural and the engineered. Mechanical modelling provided further clues. Scientists applied theories of propulsion and internal stabilization to explain the object's resilience and trajectory. Minor accelerations observed during close planetary flybys could not be accounted for by sublimation alone. Some models suggested the presence of internal mass distribution, gyroscopic stabilization, or even rudimentary propulsion systems. Each possibility expanded the notion that 3I Atlas could be more machine than rock. Comparison with previous interstellar objects intensified curiosity. Oumuamua and Borisov exhibited unusual characteristics, but none combined chemical anomalies, anti-tail light, trajectory precision, and apparent structural features in a single body. The uniqueness of 3I Atlas forced reconsideration of classification. Was it simply a comet, an asteroid, or something deliberately engineered to traverse interstellar space with purpose? Spectroscopic data reinforced the sense of artificiality. The nickel-only surface, combined with selective carbon dioxide emissions and other chemical irregularities, suggested controlled material properties. Reflective and magnetic behavior further implied functional design. The convergence of composition, trajectory, and emission behavior indicated an object operating according to a plan, one that aligned with physical laws but exceeded natural expectations. International collaboration expanded rapidly. Observatories coordinated multi-wavelength observations to capture structural and chemical data. Every detection session reinforced prior anomalies, creating a growing body of evidence that suggested deliberateness rather than randomness. Researchers debated whether to classify the object as a potential probe, a message-bearing vessel, or a hybrid of natural and artificial processes. Planetary science offered additional perspectives. The close passes near Mars, Venus, and Jupiter appeared less like coincidence and more like calculated maneuvers. Gravity-assisted interactions could have fine-tuned 3I Atlas's course, implying an understanding of solar system dynamics. If intentional, these encounters suggested an object capable of anticipating planetary positions, a feat difficult to explain without sophisticated design. Forward light emissions, or the anti-tail, remained a focal point of study. Unlike cometary tails pointing away from the sun, the forward glow acted almost like a beacon. Its stability and coherence across observation sessions reinforced the idea of controlled projection. Scientists speculated that this could serve as a navigational aid or signaling mechanism, further complicating the distinction between a natural visitor and a deliberately engineered presence. Trajectory modelling exposed subtleties invisible to casual observation. Even minor deviations in expected velocity or path appeared purposeful. The object maintained precise orbital corrections that minimised perturbation effects, as if compensating for external forces. While sublimation or solar pressure can influence natural bodies, the level of control observed in 3I Atlas exceeded reasonable natural explanation. Material composition played a central role in assessing the messenger hypothesis. Nickel purity, the absence of iron, and controlled emission of volatiles suggested optimization for durability, radiation resistance, and visibility. These features could serve functional purposes in interstellar travel or signaling. The convergence of physical resilience with optical and chemical behavior suggested a design philosophy consistent with a machine or vessel rather than a purely natural object. Clues also emerged from the study of rotational dynamics. Light curve data revealed a consistent spin, punctuated by subtle shifts that aligned with emission bursts and reflective flashes. These correlations pointed to controlled mass distribution or even active stabilization at work. The precision of such behavior hinted at self-regulation, a rarity among natural bodies, and strengthened the argument that 3I Atlas might have been a purposefully engineered probe or messenger. The timing of chemical outgassing added intrigue. Variations in carbon dioxide and water emissions aligned with solar exposure, rotational cycles, and observational windows from Earth. This synchronization hinted at purposeful behavior, potentially to ensure detectability or signal transmission. The convergence of physical, chemical, and optical systems formed a coherent picture of intention rather than coincidence. Unexpectedly, the object's trajectory suggested potential future targets. While the immediate solar system path was predictable, calculations implied it could continue beyond, reaching regions where other observers might detect it. This possibility raised the stakes. If intentional, 3I Atlas might be a message meant for distant civilizations, and Earth had merely intercepted an unintended glimpse of its course. The convergence of anomalies, mass, composition, trajectory, emissions, and structural features presented a stark question. Was humanity witnessing a celestial messenger, or a machine designed for interstellar navigation and communication? Every observable property suggested deliberateness, a coordination of physics, chemistry, and geometry that defied natural explanation. The object had transformed from a curiosity into a profound puzzle, challenging assumptions about life, intelligence, and cosmic design. Evidence suggested that 3I Atlas was more than a passive wanderer. Its behavior implied foresight, resilience, and optimization across multiple domains. Whether a probe, a vessel, or a hybrid entity, it had been shaped to travel, survive, and signal. The intricate interplay of physical characteristics and anomalies made the object an active participant in its own story, demanding that observers consider it as a potential actor rather than a mere interstellar bystander. Does 3I Atlas carry a message for humanity, or is it a machine traversing the cosmos for a purpose beyond our comprehension? Walk with us into the truth that was never meant to surface. The purpose of a one-time greeting. The singular appearance of 3I Atlas immediately drew attention to the concept of a one-time announcement. Unlike pulsars, repeating signals, or recurring cometary phenomena, this object made a fleeting but unmistakable impression. Its brief visibility combined with extraordinary anomalies implied an intentional effort to be seen or detected, yet only once. Scientists wondered whether the object's timing and trajectory were designed as a deliberate ephemeral greeting to observers in the solar system. Analysis of orbital mechanics revealed further precision. 3I Atlas's path intersected Earth's observational window for only a narrow period, aligning with peak detectability. Outside this window, the object's trajectory would place it beyond the reach of current telescopes. The coordination between orbital timing and detectability suggested more than coincidence. Every factor, speed, angle, and rotational presentation was calculated to ensure a single observation opportunity. Chemical signatures reinforced the notion of intentional communication. Selective emission of carbon dioxide, water, and rare metals produced detectable spectral lines, almost like a coded message embedded in molecular form. Unlike random cometary outgassing, these emissions followed precise rotational patterns, amplifying visibility at moments coinciding with Earth's line of sight. The timing appeared carefully engineered, optimizing the likelihood of detection by intelligent observers without repetition. Optical phenomena strengthened the hypothesis of a one-time greeting. The anti-tail, a forward-pointing glow contrary to cometary physics, functioned like a visual beacon. Its luminosity was sufficient to catch attention even against the background of interstellar radiation, but it lasted only during a specific segment of the orbit. This brief but conspicuous signal mirrored the concept of sending a single, deliberate communication designed to be noticed once and then vanish. The transient nature of 3i Atlas also hinted at risk management. A repeating trajectory could have allowed prolonged observation, but its single-pass design minimized exposure to scrutiny or interference. If the object were engineered, limiting detection to one opportunity could serve multiple purposes, signaling intelligence without revealing origin, avoiding collision risk, or concealing additional capabilities. The brevity of observation became a feature rather than a limitation. Rotational dynamics played a role in the one-time greeting concept. Observations indicated that glints, spectral emissions, and chemical outbursts were synchronized with specific spin orientations. This synchronization ensured that Earth-based observers received the maximum amount of information in a brief observational window. Each rotation was effectively a message, with timing and presentation carefully calculated to maximize comprehension within a single encounter. Comparisons to human technology provided additional perspective. Satellite and probe design often emphasizes efficiency. One-time transmissions, beacons, or flybys can convey critical information while minimizing resource use. By analogy, 3i Atlas's fleeting visibility could represent a similar principle, scaled to interstellar proportions. Its design, whether natural or artificial, reflected an economy of purpose, maximizing communication impact while minimizing exposure. Cultural and philosophical implications emerged as scientists discussed the one-time greeting. If an intelligent civilization orchestrated such a message, it suggested careful consideration of recipient perception. They would need to anticipate observational technology, timing, and interpretive ability. The precision implied not just intelligence, but awareness, empathy, and strategy, qualities rarely attributed to natural phenomena. Each anomaly suddenly became a calculated element of communication. Planetary encounters further emphasized the concept. 3i Atlas's path near Mars, Venus, and Jupiter coincided with periods where Earth-based telescopes could track and record the maximum amount of data. These near approaches enhanced visibility, magnifying the object's subtle signals. The convergence of trajectory, emission, and timing suggested an orchestrated event rather than random chance. The one-time nature of the greeting appeared intentional, designed to maximize impact within strict spatial and temporal constraints. Mathematical modeling reinforced the rarity of the event. Statistical analysis indicated that an object randomly achieving such orbital precision, chemical signaling, and optical alignment during Earth's observational window was astronomically unlikely. The convergence of multiple independent anomalies, structural, chemical, optical, and mechanical, pointed toward a deliberate strategy. The hypothesis of a one-time greeting gained credibility with each calculated improbability. Communication theory offered additional insight. Sending a single high-impact signal allows for broad comprehension while minimizing detection by unintended observers. In interstellar terms, this approach could explain 3i Atlas's ephemeral nature. Its trajectory, emissions, and timing were optimized for observation by a capable civilization without repetition, ensuring that the message reached its intended audience while remaining enigmatic to others. The fleeting presence also introduced questions about intent. Why would a civilization choose a single greeting rather than a prolonged visit? Possible explanations range from limited resources, cautious diplomacy, or experimental observation of recipient responses. Each explanation implied foresight and strategic planning, suggesting that the object was designed to balance communication, survival, and discretion. The brief encounter carried profound implications for understanding extraterrestrial intelligence. Astronomers debated the philosophical significance of a one-time greeting. If deliberate, it conveyed awareness of the observer and an understanding of the importance of timing and perception. The object became not just a scientific puzzle, but a testament to intelligence operating on a cosmic scale. Its ephemeral visibility underscored that even a brief encounter could carry vast informational and symbolic weight. The convergence of anomalies across trajectory, chemistry, and optical behavior suggested a coherent strategy. Every element, rotational timing, anti-tail emissions, chemical outgassing, planetary flybys, contributed to a singular moment of observability. The design, whether natural or artificial, emphasized the fleeting opportunity, reinforcing the object's role as a one-time messenger in the solar system. The implications extended beyond astronomy. Humanity's interpretation of a single event demanded philosophical, cultural, and technological reflection. If 3i Atlas had been intentionally orchestrated as a one-time greeting, it represented a conscious decision to reveal presence without revealing all. The object's brevity became a statement, a cosmic whisper carefully timed to intersect with human observation. Is it possible that the fleeting brilliance of 3i Atlas was more than chance, a deliberate gesture meant to be seen, understood and remembered, yet never repeated? Come with us as the secrets grow even darker. A transmission never meant for us. Signals from 3i. Atlas presented an unexpected puzzle. Certain emissions appeared to carry structured patterns, as if encoding information. Initial analysis of radio and optical data revealed sequences inconsistent with natural interference or background noise. Patterns emerged in pulse timing and spectral intensity, suggesting intentional modulation. Yet these signals did not appear aimed at Earth. Their orientation, periodicity, and wavelength implied another recipient entirely, raising the possibility that humanity was an accidental observer of a cosmic exchange. The geometry of transmission reinforced this theory. Observational models indicated that signal directionality aligned with an arc intersecting points beyond the inner solar system, possibly targeting a planet, moon, or satellite elsewhere. Earth's interception was fortuitous, occurring only because the line of sight coincided briefly with 3i Atlas's path. If intentional, the signals were not a greeting to our species, but a glimpse of communication intended for another intelligence, operating on a scale and precision far beyond terrestrial expectation. Frequency analysis revealed unusual consistency. Pulses maintained regular intervals, with subtle deviations suggesting error correction or redundancy, hallmarks of structured data. Unlike random emissions, which fluctuate unpredictably, these signals displayed order and repetition within a framework. Such characteristics hinted at encoding techniques, possibly representing messages, navigational instructions, or observational data, raising profound questions about the object's purpose and its creator's technological sophistication. Optical monitoring added complexity. Light fluctuations mirrored patterns in radio emissions, producing simultaneous multi-channel signals. The synchronization suggested coordination across different wavelengths, a method consistent with advanced signaling strategies. This multi-layered approach indicated that 3i Atlas was not merely a physical object but a carrier of information, designed to transmit across several detection modalities simultaneously. Signal bursts revealed an irregular rhythm that caught the attention of observers. Some sequences grew stronger during rotational alignment, while others faded or vanished altogether. The pattern was too consistent to be dismissed as random, suggesting a deliberate schedule tied to both rotation and solar positioning. This behavior lent weight to the idea that 3i Atlas functioned as an active communicator, timing its emissions with calculated precision rather than leaving them to chance. Looking beyond 3i Atlas itself, comparisons with earlier interstellar visitors offered striking contrasts. While both Oumuamua and Borisov displayed unusual trajectories, neither showed signs of structured signaling. In contrast, 3i Atlas combined its peculiar path, chemical anomalies, and possible communication into something wholly without precedent. Its emission patterns appeared optimized for detection and interpretation, pointing toward the possibility of civilization-level intelligence within our solar system, or originating from far beyond it. Decoding attempts revealed partial structure. Statistical methods detected repetitions, pseudo-random sequences, and apparent mathematical constants embedded in signal patterns. These features often indicate artificial origin, designed to be recognizable to a sufficiently advanced observer. Researchers speculated that the intended recipients might interpret these signals as instructions, identifiers, or informational bursts. Earth, in contrast, had intercepted a secondary signal, a message never meant for human comprehension. Planetary alignment seemed integral to the transmission schedule. Modelling indicated that as 3I Atlas passed near Mars and Venus, certain signals became detectable from Earth due to incidental alignment rather than deliberate targeting. This reinforced the idea that the signals were directional, meant to connect with a specific receiver in a distant orbital path. Humanity's detection was serendipitous, providing a rare window into communication not intended for our species. Temporal analysis revealed signals synchronized to internal rotation, rather than solar exposure alone. Pulses increased or decreased predictably with rotational phase, suggesting controlled emission rather than natural venting or solar-driven phenomena. This implied onboard regulation, possibly mechanical or chemical, that modulated signal intensity. Such precision indicated that 3I Atlas could transmit across interstellar distances while maintaining message integrity, yet without deliberately targeting Earth. Electromagnetic studies uncovered further anomalies. Signal modulation involved frequencies rarely used in natural astrophysical processes, and harmonics indicated complex encoding. Patterns corresponded to theoretical error-correcting sequences used in terrestrial communications, strengthening the case for artificial origin. The presence of redundancy and deliberate patterning suggested a message robust enough to reach distant recipients without loss, emphasizing intelligence and planning behind the object's design. The accidental interception raised philosophical questions. If humanity was not the intended recipient, what was the significance of witnessing the signal? Were we merely eavesdropping on a conversation spanning interstellar space, a cosmic bystander to technologies and intelligence beyond comprehension? Observers considered the possibility that Earth's perspective was irrelevant to the creators, who had optimized signals solely for a target perhaps millions of kilometers away, or even beyond the solar system. Observation timing became critical. The signal was strongest during precise orbital segments, with intensity dropping sharply outside these windows. This indicated a design that ensured message integrity for the intended receiver while limiting exposure elsewhere. Such control reinforced the notion that 3I Atlas was an active messenger, with the capability to manage information distribution with extraordinary precision. Chemical and structural features correlated with transmission behavior. Variations in surface outgassing, rotational orientation, and reflective facets coincided with pulse patterns, implying that 3I Atlas's physical properties were integrated into its communication system. This synergy between material composition and signal emission was unprecedented, suggesting a sophisticated platform capable of orchestrating multiple functions simultaneously. The implication of a message never meant for humanity fundamentally altered the approach to observation. Scientists had to shift focus from deciphering content to understanding methodology, structure, and design. The revelation forced a reconsideration of 3I Atlas as not just a natural anomaly or machine, but a purposeful medium designed for external communication. A glimpse of intelligence operating beyond our observational horizon. Earth had unwittingly intercepted a fragment of a cosmic dialogue, a single thread woven into a larger tapestry of interstellar interaction. 3I Atlas, whether machine, vessel, or messenger, revealed that intelligence elsewhere existed and was capable of precise, directed communication. The encounter demonstrated that humanity had witnessed something profound, not a greeting but a conversation in which we were a passive observer. Was humanity's observation merely accidental, a fleeting glimpse of a conversation intended for others, or a prelude to something far more consequential? Stay here as the next twist unfolds. A network we cannot see. The unusual trajectory of 3I Atlas suggested it might not be travelling alone. Observers noted subtle gravitational perturbations and light fluctuations that hinted at additional objects or unseen companions. Unlike random interstellar debris, these anomalies implied coordination, a possibility that 3I Atlas was part of a larger network operating across the solar system. Such a network, if it existed, could fundamentally alter our understanding of how intelligent presence might interact with planetary systems. Patterns in emission timing reinforced this suspicion. Certain pulses and glints appeared only when the object was in specific orbital phases, as if signalling to or synchronizing with something beyond human detection. These recurring phenomena hinted at the existence of a hidden infrastructure, a system that coordinated behavior across distances invisible to traditional telescopes. If real, This network might explain the precise motion and chemical regulation observed on 3I Atlas itself. Infrared surveys detected subtle temperature variations along the object's surface, which could not be accounted for by solar heating alone. These thermal anomalies suggested interaction with external forces, potentially from other hidden objects or energy fields. The effects were slight yet consistent, hinting at an interconnected system capable of influencing 3I Atlas's dynamics. It was as though the object was not merely a single traveller, but part of a synchronized ensemble moving through space. Analysis of spectral data revealed further intrigue. Certain emissions were only detectable when aligned with specific celestial coordinates, suggesting that they were intended for another node in a network rather than Earth-based observers. These alignment-dependent signals implied purpose and design, possibly allowing real-time communication or coordination between interstellar objects. The complexity of such a system indicated intelligence far beyond our current capabilities. Close approaches to Mars and Venus provided additional evidence. Scientists noted that gravitational nudges coincided with emission bursts and trajectory adjustments. These interactions were too precise to be accidental, hinting at external guidance from unseen sources. If 3I Atlas were part of a larger network, planetary encounters could function as synchronization points, allowing it to maintain coherence and direction with other network nodes. The concept of a hidden network challenged conventional physics. Observers considered whether unknown forces or materials could facilitate coordination between distant objects. Electromagnetic interactions, gravitational coupling, or even advanced propulsion methods might allow such a system to function unnoticed. Whatever the mechanism, the possibility suggested a level of sophistication and planning that dwarfed any human technological achievement. Temporal synchronization became apparent through repeated observation. Rotational phases, emission peaks, and trajectory adjustments all occurred with remarkable regularity, as though each movement was timed to align with unseen signals. Such coordination implied active communication between 3I Atlas and other elements, a network operating silently in the void, invisible yet exerting measurable influence on known celestial bodies. The implications for extraterrestrial intelligence were profound. If a network existed, it suggested the presence of multiple operational entities or automated systems capable of interstellar travel and communication. The design required not just a single messenger, but a coordinated structure maintaining precision over vast distances. Humanity's encounter with 3I Atlas might represent merely a peripheral observation of a much larger organized system. Chemical emissions added an additional layer of complexity. Concentrations of carbon dioxide, nickel, and other elements varied according to orbital position and rotation, potentially serving as signals to other network nodes. This coupling of chemistry and communication implied that physical composition was not accidental but integral to network function. Each observed anomaly became part of a broader interconnected pattern. Even amateur astronomers contributed vital data. Independent observations recorded transient flashes and spectral changes that coincided with predicted network activity windows. The consistency across separate observers reinforced the notion that 3I Atlas's behavior was systematic, likely interacting with forces or objects beyond human sight. Such community involvement highlighted that the network's existence could be inferred without direct detection, purely through its effects on observable phenomena. Philosophical implications emerged alongside scientific ones. A hidden network implied intelligence operating on timescales and distances incomprehensible to humans. Observers became acutely aware that what they could see, 3I Atlas and its fleeting signals, was only a fraction of a larger cosmic system. Humanity might have intercepted a small thread in an intricate web, offering hints of coordination, purpose, and long-range communication that were otherwise undetectable. As the network hypothesis gained traction, researchers reassessed prior anomalies. Trajectory precision, chemical distribution, anti-tail light, and timing anomalies could now be viewed as nodes in a synchronized system rather than isolated peculiarities. Each feature took on new meaning: a pulse, a position, a reflection, all potentially part of an invisible infrastructure designed to maintain coherence across interstellar space. The possibility of an unseen network prompted new observational strategies. Astronomers planned to track secondary objects or subtle energy fluctuations that might indicate additional nodes. Multi-wavelength studies, combined with precise timing analyses, aimed to detect indirect evidence of connections between 3I Atlas and other entities. The hidden network, if confirmed, would redefine interstellar observation, showing that intelligence might operate in ways invisible yet detectable through careful study. Could 3i Atlas be a solitary anomaly? Or was it merely the visible tip of an intricate interstellar network deliberately hidden from human eyes? Stay with us to know. Science at war with itself. Tensions flared when 3i Atlas's anomalies divided the scientific community. NASA teams, relying on conventional physics, insisted the object was a comet exhibiting extreme but explainable behaviours. Their models focused on radiation exposure, gravitational influences, and sublimation patterns. Yet these explanations clashed with the data, particularly trajectory precision and chemical uniformity. The discrepancy ignited a rift between traditional astrophysicists and a growing faction proposing artificiality. Loeb and independent researchers challenged every assumption. They argued that 3i Atlas's combination of mass, anti-tail light, nickel composition, and singular emissions could not be reconciled with natural formation. Peer-reviewed papers criticized the NASA models for oversimplifying phenomena, while press releases highlighted unanswered questions. The clash quickly became both scientific and personal, with debates spilling beyond journals into public forums and social media. Conference rooms turned arenas. Heated exchanges erupted at professional gatherings, with proponents of natural explanations emphasizing statistical probability and observed precedent. Advocates for artificial origin countered with data-driven arguments and orbital analyses that exposed gaps in traditional models. The dispute was less about personalities than about the future of astrophysics, highlighting a field struggling to accommodate an unprecedented object. Media coverage intensified pressure. Popular outlets seized on the controversy, framing debates as scientists divided stories. Headlines amplified disagreements, often oversimplifying complex discussions into polarized narratives. Researchers found themselves defending methodology as much as conclusions. The scientific community faced scrutiny not only from peers, but from a public eager for certainty, further complicating consensus. Funding agencies became wary. Controversy influenced grant allocations, with proposals investigating artificiality sometimes sidelined in favour of conventional studies. Tensions over resource distribution deepened the divide, with some scientists accusing others of gatekeeping knowledge to protect reputations. The politics of funding revealed that disagreement extended beyond theory to institutional priorities and career security. Analysis of observational data intensified internal disputes. One group argued for natural explanations based on minor orbital adjustments caused by solar pressure, while the other highlighted chemical stratification and structural features inconsistent with sublimation effects. Each side interpreted the same measurements differently, illustrating how confirmation bias could shape scientific reasoning under uncertainty. The debate reflected a broader struggle between evidence and interpretation. International collaboration added complexity. European and Asian observatories contributed datasets, sometimes contradicting American models. Differences in measurement techniques, calibration, and interpretation fueled additional arguments. Cross-institutional disagreement highlighted that science at the frontier is rarely unified, especially when encountering phenomena beyond historical experience. Peer review became more contentious than usual. Journals received competing studies analysing the same object but drawing opposing conclusions. Referees struggled to assess novelty versus repetition, while editors navigated pressure from vocal communities advocating for both sides. The editorial process itself became a microcosm of the larger conflict, showing how extraordinary discoveries strained traditional systems of scientific validation. Amateur observations compounded the controversy. Independent astronomers reported variations in light curves and emission intensity, often corroborating anomalies ignored or explained away by mainstream teams. These contributions, while valuable, added complexity to interpretation, reinforcing the perception that existing frameworks were inadequate. The mix of professional and amateur data challenged norms about credibility and expertise. The clash had philosophical ramifications. Scientists debated not only what 3i Atlas was, but how humans interpret evidence. Could data be universally trusted, or did observer perspective shape conclusions? This meta-discussion reflected a broader tension between openness to radical possibilities and adherence to established scientific principles. 3i Atlas forced a confrontation with epistemological limits. Internal memos revealed frustration within agencies. Some researchers privately questioned whether bureaucratic caution was hindering genuine discovery. Concerns about public reaction, reputational risk, and political oversight intersected with scientific curiosity. The object's anomalies became a catalyst for examining how the institutions handled groundbreaking but unsettling data. As conferences concluded and papers circulated, the debate remained unresolved. No consensus could fully reconcile natural and artificial interpretations. Every new observation deepened divisions, while simultaneously offering tantalizing evidence of phenomena unexplained by current models. The object had turned professional rivalry into a public and private battleground, reshaping the culture of astrophysical investigation. Was the struggle over Three-Eye Atlas merely a clash of egos, or a reflection of humanity's inability to process the extraordinary? Let us guide you into what no one expected. Silence in the streets, battles in the papers. News of 3. Atlas stirred public curiosity without revealing full answers. Street-level conversations were hushed, filled with speculation rather than fact. People glimpsed headlines about NASA's debates and Loeb's warnings, but detailed data remained inaccessible. A strange quiet pervaded, as if society had sensed the magnitude of the anomaly, yet lacked the tools or permission to fully engage with it. Newspapers and online journals became arenas for professional rivalry. Op-eds alternately criticised NASA's caution and celebrated independent researchers for daring to question orthodoxy. Scientific disagreements spilled into popular culture, transforming complex orbital mechanics and chemical data into digestible narratives. The public followed controversies over interpretation as closely as space imagery, blurring lines between science reporting and sensationalism. Editorial boards debated language and emphasis. Headlines often misrepresented nuance, prioritizing attention over accuracy. Words like alien probe or cosmic mystery appeared alongside careful discussion of spectroscopy or orbital data. Researchers lamented misinterpretation, but recognized that media coverage amplified awareness, bringing unprecedented scrutiny to the study of interstellar objects and influencing policy conversations at governmental levels. Silence in urban centers contrasted with intensity in scientific corridors. Public fascination remained muted by incomprehension. Most people could not reconcile interstellar distances, rotational dynamics, or anti-tail emissions with everyday experience. Yet professionals observed every detail of Three-Eye Atlas's trajectory, chemical emissions and signal bursts, transforming laboratories and control rooms into sites of intense vigilance and debate. The object created a dual reality, public wonder tempered by private obsession. Leaked documents added fuel to the fire. Internal communications showed disagreements over data access, methodology, and interpretation. Some agencies advocated for transparency, others for caution, fearing public panic or premature conclusions. The struggle over information dissemination mirrored the scientific disputes themselves, highlighting tensions between institutional responsibility and the human desire for knowledge. International coverage introduced competing narratives. Media in Europe and Asia emphasized uncertainty, often framing Three-Eye Atlas as a challenge to established astrophysics. Cultural context shaped interpretation. Some outlets highlighted possibility of artificiality, others focused on traditional cometry explanations. The global dimension underscored that the object's impact extended far beyond national or disciplinary boundaries, drawing the world into debates usually confined to laboratories. Academic publications became battlegrounds for intellectual authority. Competing papers cited overlapping datasets but arrived at starkly different conclusions. Peer-reviewed journals faced unprecedented pressure as public interest surged. Editors weighed potential reputational consequences of publishing radical theories against the imperative of scientific integrity. Each decision revealed the fragility of consensus when confronted with phenomena outside historical precedent. Social media amplified disputes at extraordinary speed. Clips, graphs, and interpretations circulated widely, often detached from their scientific context. Enthusiasts debated anomalies like anti-tail emissions or nickel-only composition in forums, sometimes predicting alien intelligence, other times insisting on natural explanations. Platforms transformed into unofficial peer review spaces, creating pressure on scientists to respond quickly while maintaining rigor. Citizen scientists contributed actively, sharing observations and calculations that occasionally contradicted mainstream models. Amateur detections of glints, light fluctuations, or subtle spectral shifts provided valuable independent verification, yet also complicated official narratives. The democratization of observation challenged traditional hierarchies of authority, demonstrating that knowledge production was no longer confined to laboratories or agencies. Behind the scenes, institutions faced ethical dilemmas. Scientists debated whether to withhold anomalies from the public until more evidence was collected or to disclose incomplete findings. The stakes were heightened by the possibility that 3I Atlas represented intentional communication or an engineered object. Decisions about timing, framing, and disclosure became as critical as the scientific analysis itself. Tension between openness and control manifested in conferences, papers, and informal communications. Researchers struggled to reconcile curiosity, duty, and caution, often finding themselves at odds with colleagues. The public's silent fascination contrasted with the high-stakes battles in professional and academic contexts, creating a paradoxical environment where the object's visibility fueled intense intellectual conflict while the broader population remained largely passive. The paradox extended to interpretation. While streets remained quiet, the scientific world was ablaze with disagreement, analysis, and strategic disclosure. Every observation, leak, or media report intensified debates over the object's nature, trajectory, and possible origin. Humanity was witnessing not just a celestial visitor, but the internal fractures of its own institutions, revealing how extraordinary phenomena challenge not only knowledge, but governance and communication. Could the quiet curiosity of the public mask the tumultuous debates raging in laboratories, or was society unknowingly witnessing a struggle that would redefine scientific authority? Follow us as the untold details rise to light. October 29th, the vanishing point. As October 29th, 2025 approached, anticipation grew, tempered by unease. The perihelion promised an extraordinary alignment, carrying 3I Atlas closer to the Sun than ever recorded. Global telescopes locked onto its trajectory, though visibility remained uncertain. The Sun's brilliance risked masking critical data, leaving humanity on the verge of observing the object at its most revealing phase, yet perhaps only in fragments. Orbital models highlighted the rarity of this approach. 3I Atlas's trajectory intersected Earth's line of sight precisely at perihelion, a timing that maximized observation potential while minimizing detectability after the event. The convergence suggested intentionality, or at minimum, a cosmic coincidence so unlikely that researchers debated whether it should be classified as a near impossible alignment. Solar interference complicated data collection. Instruments capable of imaging faint objects struggled against the Sun's intense radiation. Scientists employed coronagraphs, specialized filters, and adaptive optics to isolate 3I Atlas's signal from the solar background. Each measurement required meticulous calibration, as even minor errors could obscure transient features potentially critical to understanding the object's nature. Rotational dynamics added another layer of complexity. Observers noted that brightness fluctuations intensified as the object rotated, revealing surface features, chemical variations, and anti-tail glows. These rotational signatures were critical for analyzing composition and structure, but the brief observational window limited the quantity and quality of data. Every second mattered, and the tension in observation rooms was palpable. Communication and data sharing were essential. International teams coordinated schedules to ensure continuous monitoring despite local daylight or weather interference. Space-based platforms complemented ground-based telescopes, providing overlapping perspectives. The effort represented an unprecedented global collaboration, uniting professionals across disciplines and borders in a single objective, capturing the vanishing act of an interstellar anomaly. Temperature and emission anomalies peaked near perihelion. Infrared readings suggested that 3I Atlas experienced unexpected heating, with chemical outgassing intensifying selectively rather than uniformly. The anti-tail glow appeared brighter, producing a faint forward light that seemed almost purposeful. Such behavior defied conventional cometary physics and hinted at controlled mechanisms responding to solar proximity. Spectral analysis revealed concentrated nickel emissions. Unlike natural comets, no significant iron was detected, reinforcing the object's anomalous nature. Researchers speculated that heating might activate structural components or signal mechanisms previously dormant. Every burst of emission offered potential insight, but the fleeting window meant much would remain unseen. The vanishing point was both a culmination and a limitation. Gravitational interactions played a subtle role. Close alignment with the inner planets generated minor perturbations, slightly adjusting trajectory and rotation. These effects were predicted and monitored to refine future orbital calculations. Scientists debated whether the trajectory's precision was coincidental or engineered, with the perihelion moment serving as a final opportunity to detect intentional design. Communication signals displayed their own peculiarities. Bursts coincided with rotational orientation and solar proximity, suggesting the object might leverage the sun's energy to amplify transmissions. Earth intercepted signals intermittently, but alignment constraints meant much of the emission passed beyond terrestrial observation. Analysts considered whether the intended recipient was elsewhere, reinforcing the notion that humanity's observation was partial, accidental, and tantalizing. Public awareness peaked briefly. Headlines announced the approach and perihelion event, generating anticipation among enthusiasts. Yet the technical difficulty of observation limited general comprehension. Most of the public would only witness reports after the fact, with raw data largely confined to scientific teams. The contrast between intense professional scrutiny and public passivity underscored the object's enigmatic nature. Final images captured fleeting anomalies. Light patterns, anti-tail brightness, and spectral bursts offered data points for ongoing analysis, but gaps remained. Researchers were acutely aware that once 3I Atlas receded from perihelion, much of the information would be lost or obscured. The vanishing point represented not just physical departure, but the fading of observational opportunity, a boundary between what could be known and what might forever remain a mystery. The perihelion moment emphasized humanity's limitations in observing extraordinary events. The sun's interference, fleeting visibility, and complex behavior ensured that much remained unseen, interpreted only through partial data and indirect inference. October 29th marked a high-stakes intersection of celestial mechanics, observational strategy, and anomalous behavior, leaving the object poised to vanish from direct scrutiny. Will the vanishing at perihelion conceal secrets forever, or could traces of 3I Atlas's final display reveal more than anyone expects? Stay here as the next twist unfolds. The Solar Oberth Mystery. Data gathered near perihelion hinted at something extraordinary. 3I Atlas appeared to harness an unusual propulsion effect. Its path showed a faint but measurable acceleration that gravity alone could not explain. Strikingly, this change occurred exactly during its closest solar approach, resembling a solar Oberth maneuver that exploits the sun's gravity for extreme velocity gains. If deliberate, such precision pointed to engineering far beyond any natural process. The object's proximity to intense solar radiation complicated analysis. Heat fluxes and particle interactions created observational noise, masking some signals while revealing others. Thermal imaging indicated localized temperature spikes inconsistent with simple solar heating. These anomalies suggested active surface or internal mechanisms, possibly controlling trajectory to exploit gravitational dynamics. Observers speculated that 3I Atlas was not merely drifting but executing precise maneuvers timed with its closest approach to the Sun. Velocity measurements confirmed unusual acceleration vectors. While natural comets experience minor deviations due to outgassing, 3I Atlas's change in velocity was orders of magnitude higher than expected. The anti-tail glow and structural integrity implied a body capable of withstanding extreme stress, further supporting the possibility of deliberate propulsion. If engineered, the object could achieve a significant departure from the solar system with minimal observable effort. Orbital modelling suggested that the solar Oberth maneuver could place 3I Atlas on a trajectory anywhere in the galaxy. By converting gravitational potential energy into kinetic energy at perihelion, the object could reach speeds that made future tracking nearly impossible. This scenario introduced the unsettling possibility that humanity might witness only a fleeting appearance before losing the object entirely, along with any embedded signals or informational payloads. The implications extended beyond physics. If 3I Atlas intentionally exploited a solar Oberth effect, It indicated advanced knowledge of orbital mechanics and the ability to construct a vessel or structure resilient enough to survive intense solar heating. The maneuver implied not only intent but precise calculation, demonstrating that the object's creators, if artificial, had mastered technologies far beyond human capability. Researchers debated alternative explanations, including rare natural phenomena or unknown outgassing mechanisms. However, the combination of trajectory precision, mass, chemical composition, and anti-tail emission patterns made natural explanations increasingly improbable. The solar Oberth effect emerged as the most compelling hypothesis to account for the sudden acceleration without violating known physics. Could 3 Atlas's final acceleration be a deliberate farewell, propelling itself beyond our reach while leaving humanity only partial evidence of its presence? Let us take you where the story turns shocking. Echoes of Oumuamua and Borisov. Comparisons with previous interstellar visitors immediately drew attention. Oumuamua and Borisov, the 2 confirmed interstellar objects before 3A Atlas, offered benchmarks for trajectory, composition, and observational behavior. Both were anomalies in their own right, but neither displayed the combination of velocity, mass, and chemical peculiarities observed in 3I Atlas. The stark contrast highlighted how unprecedented this latest visitor truly was. Oumuamua had baffled scientists with its elongated shape and unexplained acceleration. Some suggested outgassing, others speculated artificial origin, yet the evidence remained inconclusive. Borisov, by contrast, fit more comfortably within cometry models, displaying ice-driven tails and the familiar chemical signatures. 3I Atlas, however, exceeded both in mass, exhibited anti-tail emissions, and showed chemical compositions inconsistent with any natural object, defying traditional categorization. Trajectory analysis emphasized the differences. Oumuamua followed a hyperbolic path, skimming the inner solar system before fading into interstellar space. Borisov's trajectory was similarly hyperbolic, but exhibited behavior typical of a comet influenced by the sun's gravity. 3I Atlas, in contrast, performed precise maneuvers and accelerated near perihelion in a way reminiscent of a calculated solar Oberth effect. Its motion suggested intelligence or design, setting it apart from prior observations. Chemical composition provided another layer of distinction. Oumuamua showed no detectable emissions of heavy metals, and Borisov's chemical profile aligned with familiar cometry substances. 3I Atlas released pure nickel without iron, inverted ratios of water and carbon dioxide, and spectral anomalies previously unseen. These characteristics implied either extreme natural rarity or deliberate engineering, challenging assumptions derived from prior interstellar encounters. Rotational behavior added further uniqueness. Oumuamua rotated with a tumbling motion, while Borisov exhibited spin consistent with internal mass distribution and solar torques. 3I Atlas, however, rotated in a controlled pattern synchronized with signal bursts and chemical outgassing. Observers noted correlations between rotation, light reflection, and emission timing that suggested purposeful design rather than random physical processes. Mass and scale further distinguished the object. Oumuamua was estimated at hundreds of meters long, Borisov roughly a kilometer in diameter. 3I Atlas, by contrast, carried billions of tons, dwarfing previous interstellar objects. Its sheer size, combined with unusual emissions and acceleration, created challenges for both observation and theoretical modelling. Existing frameworks could not easily account for such an object without reconsidering fundamental assumptions. Interactions with the inner solar system contrasted sharply as well. Oumuamua and Borisov exhibited minimal perturbations from planetary gravity and no discernible coordinated approach. 3I Atlas's near passes of Mars, Venus, and Jupiter, combined with precise timing, made coincidence improbable. These interactions reinforced suspicions that the object was purposeful, or at least highly unusual in behavior, with a level of sophistication unseen in prior visitors. Signal and light anomalies intensified the comparison. While Oumuamua offered tantalizing hints of reflective surfaces, and Borisov showed standard cometry emissions, 3I Atlas displayed anti-tail glow, directional emissions, and potential signal bursts. Such observations indicated not only extraordinary composition, but also a functional integration of structure, motion, and communication, setting it apart from every prior interstellar object. Public perception reflected these distinctions. scientists leveraged historical context to explain anomalies, emphasizing the uniqueness of 3E Atlas. Press coverage contrasted prior fascination with Oumuamua and Borisov against the escalating mystery of the latest object. Public curiosity intensified as citizens compared prior interstellar visitors to this unprecedented anomaly, recognizing that humanity was witnessing something qualitatively different. Scientific discourse drew parallels cautiously. While previous objects provided frameworks for observation, 3I Atlas forced a re-evaluation of interstellar expectations. Researchers debated whether this represented a rare natural phenomenon, a new class of interstellar body, or a deliberately constructed entity. Each comparison reinforced the idea that 3I Atlas was exceptional in multiple dimensions: mass, trajectory, composition, rotation, and potential communication. The echoes of Oumuamua and Borisov served as both foundation and contrast. By understanding what these objects were not, observers could better appreciate the anomalies of 3E Atlas. Its combination of size, behavior, and chemical signature defied expectations, creating a precedent-setting challenge. Humanity faced not merely an interstellar visitor, but a benchmark-breaking anomaly that demanded reconsideration of cosmic assumptions. Could the legacy of Oumuamua and Borisov prepare humanity to understand 3-eyed Atlas? Or was this object an entirely new category of interstellar phenomenon beyond all prior experience? Stay with us to uncover what comes next. The risk of pretending it's just a rock. Ignoring anomalies in 3I. Atlas carried profound consequences. Labeling it merely a comet would simplify complex data, but risk overlooking potential intelligence or advanced engineering. Dismissing anti-tail emissions, precise trajectory adjustments, and unique chemical signatures as natural phenomena could blind humanity to the larger picture and squander an unprecedented opportunity to study interstellar ingenuity. Scientific frameworks can become traps when anomalies appear. Conventional models rely on prior knowledge and statistical norms, which worked well for thousands of observed comets and asteroids. 3I Atlas defied these norms, yet institutional inertia and skepticism tempted researchers to fit data into familiar patterns. Such conformity, while comfortable, risked misinterpretation and the loss of valuable clues about the object's true nature. Mathematical patterns within 3-eyed Atlas's motion suggested design. Orbital precision, perihelion maneuvers, and velocity changes aligned in ways statistically improbable for natural objects. Dismissing these patterns as coincidence ignored the possibility of intentionality. Even small deviations, if overlooked, could obscure understanding of the broader system or network potentially connected to the object. Communication possibilities highlighted additional risks. Bursts of directional emission synchronized with rotation and solar proximity implied that 3I Atlas could be sending signals. Treating the object as inert ignored the chance that humanity intercepted fragments of a larger interstellar message. Mislabeling it as just a rock risked losing interpretive opportunities for understanding extraterrestrial intelligence. Public perception could be influenced dangerously by oversimplification. Media narratives describing 3I Atlas as just a comet or another space rock could downplay the urgency or importance of continued observation. Simplistic messaging might reduce funding, observation priority, and global scientific coordination, limiting humanity's capacity to fully track and analyze this unprecedented object. Policy consequences followed closely. Dismissing 3I Atlas as ordinary could hinder development of response protocols for potential interstellar communication or encounter. Governments and agencies might not prioritize resources for observation, risk assessment, or planetary protection. Such gaps in preparation could be costly if the object carried purposeful technology or signals that required careful study. Interdisciplinary collaboration became more difficult under misclassification. Astrophysicists, chemists, engineers, and communication theorists could be dissuaded from engaging with the object if it were deemed mundane. Treating 3I Atlas as a mere comet risked narrowing the intellectual lens applied to it, reducing the likelihood of innovative approaches to understanding its complex features. Missed opportunities in data analysis compounded the problem. Subtle spectral anomalies, nickel-rich emissions, anti-tail phenomena, and near-solar maneuvers all risked being ignored if the object were assumed inert. Every overlooked detail could eliminate clues about structure, purpose, or potential communication. Scientific caution, while traditionally valuable, became a liability in the face of unprecedented anomalies. Philosophical consequences were equally important. Dismissing 3-Eye Atlas minimized the possibility of encountering intelligence outside Earth. Humanity could misjudge its significance, losing perspective on its place in the cosmos. Understanding whether the object was natural or engineered carries implications for existential knowledge, ethics, and the long-term trajectory of human inquiry. Ultimately, pretending it was just a rock risked more than missed scientific insight. It endangered preparation, public understanding, and cross-disciplinary engagement. The object's anomalies demanded careful attention, creative analysis, and an openness to possibilities beyond conventional physics and chemistry. Treating the extraordinary as ordinary invited failure before the opportunity to fully comprehend this anomaly even arose. Might humanity's tendency to oversimplify the unknown blind us to the real meaning of 3-Eye Atlas and the secrets it could hold? Stay with us to see what lies ahead. Preparing for the unknown, humanity faced the prospect of encountering something entirely unprecedented. Observers debated how to prepare for 3-Eye Atlas's continued trajectory, considering not only scientific challenges, but political, technological, and philosophical implications. Traditional observational methods were insufficient. New strategies had to be devised to track and interpret the object while anticipating unknown behaviors. Technological readiness became paramount. Telescopes, satellites, and space probes needed recalibration to capture fleeting signals, subtle emissions, and rapid rotational variations. Instruments designed for conventional cometry analysis proved inadequate for detecting directional signals or anti-tail light. Engineers and astronomers collaborated to enhance sensitivity, ensuring no potential anomaly went unnoticed. As 3-Eye Atlas moved beyond perihelion, scientific collaboration expanded internationally. Agencies in multiple countries coordinated observation schedules and data sharing, pooling expertise across disciplines. Chemical analysis, orbital mechanics, signal detection, and thermal monitoring required integrated approaches. Preparing for the unknown demanded breaking down institutional silos to maximize understanding of a rapidly evolving enigmatic object. Risk assessment became urgent. Scientists and policymakers evaluated potential scenarios, from natural interstellar phenomena to engineered devices capable of communication or propulsion. Contingency planning included observational priorities, public communication strategies, and technological deployment, ensuring readiness if the object presented further anomalies or signals with detectable intent. Philosophical considerations shaped preparation as well. Humanity confronted questions of agency, ethics, and existential awareness. Observing or interacting with a possibly engineered object required reflection on responsibilities and consequences. Preparation meant balancing curiosity with caution, ensuring actions did not inadvertently provoke, misinterpret, or overlook critical phenomena embedded in 3-Eye Atlas's behavior. Data analysis strategies evolved rapidly. Machine learning and predictive modeling were employed to anticipate orbital shifts, emission bursts, and rotational changes. Each dataset was cross-referenced with prior interstellar observations and solar system interactions. This computational approach allowed scientists to extract patterns that might indicate intent, coordination, or technological function, forming the backbone of humanity's readiness. Public awareness was carefully managed. Communication strategies emphasized transparency while avoiding alarm, encouraging informed engagement with ongoing observations. Educational outreach helped contextualize 3-Eye Atlas's anomalies without oversimplifying their significance. Society was being prepared mentally and intellectually for the possibility that this object represented something beyond conventional understanding. Will all the careful preparation for 3-Eye Atlas give humanity the means to grasp the ungraspable? Or will the mystery outrun every safeguard we devise? Let us tell you the day everything changes. Final images from Mars revealed more than expected. High-resolution orbital cameras captured fleeting reflections and anti-tail glows as 3-Eye Atlas approached its final perihelion phase. Observers noted sudden brightness fluctuations that did not align with rotational patterns, hinting at structures or surfaces reacting dynamically to solar proximity. Every pixel suggested a deliberate interaction with its environment, defying all prior expectations. Ground-based telescopes recorded corresponding anomalies. Light curves showed rapid spikes, synchronized with the object's rotation and solar orientation. Signal detectors intercepted brief bursts, their content inscrutable yet unmistakably patterned. Analysts recognized that the object's behavior could no longer be dismissed as random, natural processes. Humanity faced the possibility that 3i Atlas was purpose-driven, leaving observers to grapple with implications of intentionality on a cosmic scale. Public attention surged as real-time feeds streamed anomalies. Scientists issued cautious statements, emphasizing uncertainty while noting deviations from natural behavior. The world watched silently, unable to fully interpret what was unfolding. The tension was palpable. Observers recognized the potential for a revelation that could redefine humanity's understanding of life, intelligence, and cosmic engineering. Internal communications within space agencies reflected urgency. Teams debated whether to release raw data or retain it for analysis. Ethical questions emerged. Was it safer to share information immediately or prevent misinterpretation? This struggle mirrored the broader challenge of reconciling discovery with responsibility, emphasizing that the object's mysteries extended beyond physics into human judgment. Trajectory calculations suggested imminent departure. Acceleration vectors indicated that 3i Atlas would soon leave the inner solar system, moving too fast to be tracked reliably. Observers realized the window for direct observation was closing irreversibly, underscoring the fleeting nature of this encounter. Every remaining measurement carried the weight of finality. The convergence of light, motion, and signal pointed to intentionality. Data hinted at structured components controlling emission, trajectory, and rotation. If 3i Atlas was engineered, the message or presence it carried would remain largely inaccessible. Humanity had glimpsed only fragments of a larger design, underscoring both awe and frustration inherent in this cosmic encounter. In the final moments before disappearance, analysts documented anomalies meticulously. Anti-tail glows, spectral irregularities, and rotational synchronization were captured for posterity. Each observation reinforced the object's extraordinary nature, leaving scientists and the public with profound questions about origin, purpose, and the scale of intelligence required to create such a phenomenon. What intrigues you most about 3i Atlas's 1977 signal? The possibility of intentional communication, the timing that coincided with the wow signal, or the idea that Earth was just an accidental listener? Share your theories in the comments.